Hello everyone, welcome to Tech with Shaping Pixel. We are bringing you free cloud certification crash course. This time we are bringing AWS certified cloud practitioner course which is also CLF C02. The best way to gain this certification is to complete these crash course and practice the exams questions provided. This video is specially curated to help you pass the AWS Certified Cloud Practitioner exam and is ideal for anyone who is looking to learn about the various compute services in AWS in preparation for the exam. This fundamental certification is designed for individuals with exposure to AWS and its services, even if they are not in a technical role. Key exam domains. The certification covers four domains: cloud concepts 24%, security and compliance 30%, cloud technology and services 34%, billing, pricing and support 12%. Each domain includes task statements outlining required knowledge and skills. Cloud concepts. These domain accounts for 24% of the exam content and focuses on four key areas. Define the benefits of the AWS cloud. Identify design principles of the AWS cloud. Understand the benefits of and strategies for migration to the AWS cloud. Understand concepts of cloud economies. Security and compliance. These domain accounts for 30% of the exam content and focuses on four components of cloud security. Understand the AWS shared responsibility model. Understand AWS cloud security governance and compliance concepts. Identify AWS access management capabilities. Identify components and resources for security. Cloud technology and services. These domain accounts for 34% of the exam content and has 8 key areas of interest. Define methods of deploying and operating in the AWS cloud. Define the AWS global infrastructure. Identify AWS compute, database, network, and storage services. Identify AWS artificial intelligence and machine learning services and analytics services. Identify services from other in-scope AWS service categories. Billing, pricing, and support. These domain accounts for 12% of the exam content and accesses you in three areas. Compare AWS pricing models. Understand resources for billing, budget, and cost management. Identify AWS technical resources and AWS support options. Ever wondered what cloud computing really is? So let's break it down. So before understanding cloud computing, it's important to grasp virtualization. It allows multiple virtual machines to run on one physical server, sharing hardware resources through a hypervisor. These maximizes the power of cloud computing. So cloud computing is a rapidly growing technology offering a remote virtual pool of on-demand shared resources including compute, storage, database, and network services. It's changing the landscape of how many companies operate with significant business and technical advantages. So let's deep dive into core foundation services. In cloud computing, core foundation services include compute, storage, database, and network resources. Understanding these will help identify what services to move to the cloud. So cloud computing is a game changer, offering scalable on-demand resources. Stay tuned for more on cloud deployment models. So let's understand different cloud deployment models. The three main cloud deployment models are public, private, and hybrid. The public cloud model offers shared infrastructure accessible over the internet for public usage. It's maintained by the cloud vendor, providing flexibility and scalability. On the other hand, the private cloud is a privately hosted, managed, and owned by individual companies, offering greater control and security. In a private cloud, all resources are isolated and in the control of one organization. So the private cloud is also called the internal or corporate cloud. Lastly, the hybrid cloud combines both public and private clouds, allowing for seasonal burst traffic or disaster recovery. It extends the logical internal network of the private cloud, offering the benefit of both models. So let's have a quick overview of the key characteristics of cloud computing. So on-demand resourcing. Cloud computing offers on-demand resourcing, meaning that the resources are immediately available for allocation, eliminating the need for wait for hardware to be ordered, installed, and configured. Scalability. With cloud computing, you have the ability to rapidly scale your environment's resources both up and down and in and out, depending on your requirements and demands of your application and services. Economy of scale. Thanks to virtualization technology, cloud computing provides an economy of scale, resulting in exceptionally low resource cost compared to traditional hosting. Flexibility and elasticity. Cloud computing offers huge flexibility and elasticity, allowing you to fully customize your environment using only the resources required. Utility-based metering. Many cloud services operate on a utility-based metering system, meaning you only pay for the resources you use. So let's dive into cloud service models. The three main cloud service models are software as a service, platform as a service, and infrastructure as a service. Each model offers varying levels of manageability and customization over your solution. Software as a service, or SaaS, provides widely distributed and accessed applications like Google's Gmail. These applications are fully managed by the provider and accessed over the internet, offering minimal customization from the user's perspective. Platform as a service, moving up the customization scale, platform as a service or PaaS offers a greater level of management and control. It provides an application framework on top of the operating system, allowing developers to focus on creating new apps. And lastly, infrastructure as a service or IaaS allows the highest level of customization. Users can configure their own portion of the cloud, including virtual networks and operating systems, while the underlying host is managed by the vendor. Let's dive into some of the common use cases of cloud computing and how enterprises are leveraging these technology. Migration on the cloud. One of the major use cases of cloud computing is migrating production services from on-premises solutions to the cloud. With the benefits of scalability and cost effectiveness in mind, many businesses are choosing to move their existing production services to the public cloud. Traffic bursting. During peak season, the public cloud can be used to scale networking resources to manage additional traffic. This means you only pay for the extra infrastructure when you need it, making it a cost-effective solution for handling fluctuation traffic. Backup and disaster recovery. The built-in resiliency and durability of public clouds make them a great solution for backup and disaster recovery needs. With access to unlimited storage space and cost-effective data management lifecycle policies, cloud computing is becoming a popular choice for enterprises. Web hosting. Many organizations are opting to host their web services on the cloud due to its ability to load balance across multiple instances and scale up and down quickly based on traffic demands. So let's dive into cloud computing infrastructure. Location. In an on-premises data center, infrastructure is housed on-site and across multiple locations for residents. Similarly, public cloud providers have regions with at least two data centers in different geographic locations, ensuring high-speed interconnectivity and data transfer. Physical security. Public cloud vendors are responsible for stringent security controls and certifications, ensuring the physical security of the data center. Mechanical and electrical infrastructure, the responsibility for implementing capacity, resiliency, and testing for mechanical and electrical infrastructures in the data center lies with the vendor, removing these burden from the end user. Network infrastructure in the public cloud, networking operates at a software level, allowing the implementation of control services and configuration to simulate the effects of physical network components. Servers and storage. Cloud vendors offer services replicating the functions of servers and storage in on-premises data centers with added advantages such as scalability and durability. The public cloud environment easily translate on-premises data center solutions, offering significant advantages and benefits. Let's explore the benefits of cloud computing for organizations. On-demand resourcing. One of the key advantages of cloud computing is on-demand resourcing. This means that when you need to provision a resource within the cloud, it's almost immediately available to you to allocate where and when you need it. This alleviates the lengthy process of sourcing additional resources for your infrastructure, providing almost instant access to a resource that you have selected and configured via a series of options. Scalability. Cloud computing offers the ability to rapidly scale your environment's resources both up and down and in and out depending on your requirements and demand of your applications and services. This is only possible because of the on-demand resourcing of the cloud. Economy of scale. Due to the huge scale of resources public cloud offering provide, you benefit from exceptionally low compute storage and network cost compared to traditional hosting. Public cloud providers can make use of these when buying infrastructure in huge scales, passing on the savings to you. Flexibility and elasticity. Cloud computing offers huge flexibility and elasticity to your design approach, allowing you to deploy different resources and services within minutes or seconds. This flexibility is often coupled with automation, ensuring your infrastructure will always deliver great service to your customers. Utility-based metering. With many cloud services, you only pay for what you use. This means you only pay for resources when you are using them, similar to paying for electricity when you use it. Shared infrastructure. Hosts within the cloud are virtualized, allowing for shared infrastructure, which significantly reduces the amount of physical hardware required, resulting in cheaper cost for you. So let's dive into advantages of cloud computing for businesses. The cloud offers a new wave of life to your businesses and its architecture, providing new ways of working, deployment, and automation. It presents a massive potential within your businesses to innovate and take advantage of new services and technologies. For example, serverless computing can be a game changer, allowing you to focus solely on your code. These can lead to faster production release and innovation, helping you bring new products and applications to market more quickly. The cloud also helps businesses reduce their carbon footprint, making it a huge plus point as a differentiator in leading change for the better. Additionally, it allows for remote working, reducing cost and increasing the scope for talent sourcing. Furthermore, it reduces business risks such as data durability and product risks while making the business more dynamic and efficient. Utilizing the cloud can open up access to data and services for authorized third-party vendors, providing significant benefits and leading to a change in business strategy, making your organization stronger within the market. Let's dive into the world of AWS accounts and the services they house. Account management. AWS services are housed within an account, which can be a master payer account or a linked account. AWS organizations and other services can be used to manage accounts within AWS. Reserved instances and savings plans. Reserved instances (RI) are a commitment to use a cloud resource for a specific period in exchange for a discount rate. Savings plans (SP) are similar but more flexible. They can only be applied to compute usage. Instance types and sizes. AWS supports a variety of instance types, families, generations, and sizes. For example, an instance like M5A 4x large belongs to the M family, 5th generation, A for AMD chipset, and 4 into large size. Tags and governance. Tags are metadata attached to AWS resources, providing contextual information. They can be used for automation, cost division, and governance policies. Console and region. The AWS console is a web-based portal for managing accounts and accessing services. AWS also has the concept of regions and availability zones, which are essential for disaster recovery and performance. So whether it's managing accounts, understanding reserved instances, or utilizing tags, AWS offers a wide array of tools and services for cloud management. Let's dive into the world of DevOps and related concepts in AWS. Let's explore the key terms and practices that are shaping the landscape of software development and operations. DevOps is all about breaking down traditional silos between developers and operators of computer systems. It's about collaboration, consistency, efficiency, and automation in software delivery. By combining teams and practices, DevOps aims to revolutionize and the way software is developed and deployed. Enterprise architecture (EA) provides the blueprints for building and maintaining systems to achieve business goals. Like physical architects, EA groups outline the structure of systems, the software concept to be used, and the desired end. The lift and shift. Lift and shift migration involves moving applications from on-premises data center to public clouds. While it's a quick method, it may lead to increased cost and operational challenges due to the lack of modification for cloud native services. Workload refers to an application or software system running on a computing platform. It's the backbone of traditional and cloud-based systems, defining the resources needed to run applications efficiently. On-premises and right sizing. On-premises refers to company-owned data center space, while right sizing optimizes virtual resources to match workloads efficiency, minimizing waste and cost. Agile. Agile project management is characterized by short phases of work, frequent assessment of priorities, and incremental development of products or software. It's all about adaptability and continuous enhancement. That's a wrap on our journey through DevOps and related concepts. Stay tuned for more insights. Let's dive into the world of cloud and finance terminology. Amortization. Amortization means retiring a payment of capital gradually over time on a schedule which reflects the benefits the capital provides in each period. It's like depreciation, but it typically applies to the retirement of cash payments. Variable cost. Variable cost are costs that vary according to the business value it supports. For example, a company hosting websites would need to pay for more computers to host more websites, making the cost per website a variable cost. Upfront charges. Upfront charges for reserved instances or saving plans can be purchased with a full upfront payment, a partial upfront payment plus a reduced periodic charge, or with no upfront charge. The upfront charge may be amortized over the life of the RI. OPEX, or operating expenditure, is a category of business expense made in a specific accounting period which provides benefits only in that accounting period. Purchasing on-demand cloud services is considered an operating expenditure. ROI, return on investment, is the amount of profit from an investment made, usually expressed as a percentage of the original total cost invested. Let's dive into the world of well-architected framework in AWS. The well-architected framework is a comprehensive document provided by AWS offering best practices and lessons learned for all customers. It's organized around six pillars: security, reliability, operational excellence, performance efficiency, cost optimization, and sustainability. The goal of the well-architected framework is to access and improve AWS architecture implementation by providing a catalog of questions around each pillar. These helps in understanding the business impact of design decisions and evaluating architecture using a consistent set of best practices. The framework is not about implementing details or architectural patterns, but rather a set of questions to help evaluate architecture. It addresses key areas such as protecting data and systems, using compute resources efficiently, eliminating unneeded expenses, running workloads with automation, and reducing resource utilization. The six pillars include security, performance efficiency, cost optimization, operational excellence, sustainability, and reliability. Each pillar addresses specific aspects of architecture and best practices for AWS implementation. So in summary, the well-architected framework is a valuable resource developed by AWS experts to help evaluate architecture and ensure adherence to best practices across six critical categories. Components that make up the AWS global infrastructure: availability zones, regions, edge locations, regional edge caches, local zones, wavelength zones, and outpost. So let's dive into each components separately. AWS availability zones are the physical data centers of AWS where compute, storage, network, and database resources are hosted. It's important to note that a single AZ is not equal to a single data center. In fact, multiple data centers form a single AZ. Each AZ is geographically located within the same area, linked by highly resilient and low latency connections. These connections are used by AWS services to replicate data for high availability and resilience purposes. High availability and resilience. Utilizing resources across multiple AZs within a region allows you to create highly available and resilient applications and services. By architecting your solutions to utilize resources across more than one AZ, you ensure minimal or no impact to your infrastructure in case of an AZ failure. It's always a recommended best practice to make use of at least two AZs in a region to maintain high availability of your infrastructure. Let's dive into the concepts of regions and how they impact your cloud infrastructure. A region is a collection of availability zones that are geographically located close to one another. AWS has deployed them across the globe to allow its worldwide customers base to take advantage of low latency connections. Each region will act independently of the other and will contain at least two availability zones. Selecting the right region is crucial for optimizing latency responses times for your customers. It also allows for compliance with regulations, laws, and governance related to data storage. Plus, utilizing multiple regions creates a level of high availability crucial for business continuity. At the time of publishing this video, there are currently 32 regions and 102 availability zones with 4 additional regions and 12 additional AZs planned. It's important to note that Not all AWS services are available in every region. So understanding which services are available varies key. So when it comes to architecting your cloud infrastructure, choosing the right region is a decision that can significantly impact the performance, compliance, and availability of your services. So let's dive into the role of edge locations. Edge locations are AWS sites strategically deployed in major cities and highly populated area worldwide. They're not used to deploy main infrastructures like EC2 instances or VPCs, but rather by AWS services such as CloudFront and Lambda Edge to cache data and reduce latency for end user access. So the benefits are by leveraging edge locations as a global content delivery network, AWS ensures that end users accessing your services experience reduced latency. For example, when a user accesses a website hosted on EC2 instances and S3 from Europe, they are redirected to their closest edge location in Europe, significantly reducing latency. So the next time you access a website or app, remember the role of AWS edge locations in delivering a seamless and fast user experience. AWS global infrastructure is truly at the forefront of optimizing digital experiences. So let's dive into AWS Regional Edge Cache. In November 2016, AWS introduced the Regional Edge Cache, a pivotal addition to their infrastructure. Unlike individual edge locations, the regional edge cache has a larger cache with retaining data that has expired at the edge locations. So the benefits of regional edge cache, this means that when the data is requested at an edge location and is no longer available, the regional edge cache steps in, reducing latency by serving the cached data instead of retrieving it from the original servers. Experience faster, more efficient content delivery with AWS Regional Edge Cache. So let's dive into local zones. In 2022, Amazon launched its first 16 local zones, strategically positioned near highly populated area without an AWS region nearby. These zones provide ultra low latency and cater to data residency requirements. AWS local zones are currently available in 33 metropolitan areas with 19 more planned for the future. They are seamlessly connected to a parent region, enabling access to all other AWS services via a secure, dedicated, high-speed connection. In August 2023, AWS introduced dedicated local zones, offering fully managed infrastructure for exclusive use by specific customers or communities. These zones are ideal for mission critical and sensitive workloads, especially in sectors with strict governance controls. Experience the power of AWS local zones and dedicated local zones for your resource deployment and data residency needs. So let's introduce AWS wavelength zones. Much like AWS local zones, AWS wavelength zones place core AWS services closer to large end user bases and are connected to a parent region via a secure, dedicated high-speed connection. However, that sets wavelength zones apart is that they are embedded within 5G mobile broadband networks and are deployed within the data centers of large telecommunications providers. So the benefits of AWS wavelength zones are by deploying AWS resources such as VPC subnets, EC2 instances, and EBS volumes to an AWS wavelength zone, developers can offer ultra low latency and increased reliability for 5G applications such as live video streaming and interactive gaming. This is achieved by reducing the number of network hops and eliminating the need for any traffic to traverse the public internet. So currently AWS wavelength zones are available through Verizon in the United States, KDDI in Japan, SK Telecom in South Korea, Vodafone in the UK and Germany, and Bell in Canada. So experience the power of AWS wavelength zones and take your 5G applications to the next level. AWS Outpost, bringing the capabilities of the AWS cloud to your on-premises data center. AWS Outposts bring the same hardware used by AWS within their data centers to your on-premises data centers, allowing you to use native AWS services including EC2, ECS, EKS, S3, RDS, and EMR on-premises. Outposts can be connected to AWS using either a direct connect or VPN connection, and they are fully managed, eliminating the need for patch management and software updates. Experience the power of AWS in your own data center with AWS Outposts. Let's dive into computer services in AWS. Elastic Cloud Compute EC2, Elastic Container Services ECS, Elastic Container Registry ECR, Elastic Container Service for Kubernetes EKS, Elastic Beanstalk, AWS Lambda, AWS Batch, Amazon Lightsail. So let's see what is compute. Compute resources are the brains and processing power required by applications and systems to carry out computational tasks via a series of instructions. These includes common server components like CPUs and RAM. In AWS, there are various services and features that offer compute power from hundreds of EC2 instances to serverless AWS Lambda functions. These resources can be consumed in different quantities and for different length of time, depending on your business requirements. Let's dive into the world of Amazon EC2. Amazon Elastic Compute Cloud or EC2 is a fundamental compute service within AWS, allowing you to deploy virtual servers within your environment. Today, we will explore the key components of the EC2 service. Amazon Machine Images. So we have Amazon Machine Images or AMIs. These are templates of pre-configured EC2 instances, enabling you to quickly launch new instances based on the defined configurations. With a wide range of AMIs available, including those from the AWS Marketplace and Community AMIs, you have plenty of options to choose from. So let's talk about instance types. These define the size of the instance based on parameters like CPU's memory and storage, from general purpose to storage optimized. This is a variety of instances families to cater to different performance needs. Moving up to the purchasing options, AWS offers on-demand instances, spot instances, reserved instances, and on-demand capacity reservations. Each option is designed to optimize cost and suit different deployment scenarios. Lastly, we will touch on EC2 tenancy. By default, instances run with shared tenancy, but dedicated tenancy options like dedicated instances and dedicated hosts are available for specific security and compliance needs. And that's a wrap up on our introduction to Amazon EC2. Stay tuned for more insights into the world of AWS. Let's see an overview of the Amazon EC2 container service, also known as Amazon ECS. Amazon ECS allows you to run Docker-enabled applications packaged as containers across a cluster of EC2 instances without the need to manage a complex cluster management system. The service abstracts the burden of managing your own cluster management system by passing that responsibility over to AWS, especially through the use of AWS Fargate. When launching your ECS cluster, you have the option of two different deployment models, a Fargate launch and an EC2 launch, each with its own set of benefits and use cases. So monitoring is taken care of through the use of AWS CloudWatch, which will monitor metrics against your containers and your cluster. The cluster is dynamically scalable, meaning you can start your cluster as a single small instance, but it can dynamically scale to thousands of larger instances. Amazon ECS provides a powerful and flexible solution for deploying and managing containerized applications, allowing you to focus on building great applications and deploying them across your scalable cluster. So, introduction to AWS Elastic Container Registry or ECR. This service provides a secure location to store and manage your Docker images, allowing for easy distribution and deployment across your applications. The ECR consists of several key components, including the registry, authorization token, repository policy, and image. The registry is where you can host and store your Docker images, and it comes with the default URL with your AWS account. To access your registry, your Docker client needs to be authenticated as an AWS user using an authentication token. This token is obtained by running the get login command using the AWS CLI. Access to your registry and images can be controlled via IAM policies and repository policies, allowing for tougher security controls. You can assign permissions to each repository, controlling actions such as push and pull. So let's dive into the world of EKS, Elastic Container Service for Kubernetes. So Kubernetes is an open source container orchestration tool designed to automate, deploy, scale, and operate containerized applications. It's container runtick agnostic, meaning it can run Rocket and Docker containers. With EKS, AWS provides a managed service allowing you to run Kubernetes across your AWS infrastructure without having to take care of provisioning and running the Kubernetes management infrastructure in what's referred to as the control plane. The AWS account owner only need to provision and maintain the worker nodes. The control plane schedules containers onto nodes and tracks the state of all Kubernetes objects. In EKS, AWS is responsible for provisioning, scaling, and managing the control plane. Worker nodes are the responsibility of the customer and run as on-demand EC2 instances. To start using the EKS service, you will need to create an EKS service role, an EKS cluster VPC, install kubectl, and the AWS IAM authenticator. Create your EKS cluster, configure kubectl for EKS, provision and configure worker nodes, and configure the worker node to join the EKS. Your EKS cluster and worker nodes are now configured and ready for you to deploy your applications with Kubernetes. Now let's dive into overview of AWS Elastic Beanstalk. So Elastic Beanstalk is an AWS managed service that simplifies the process of deploying, provisioning, monitoring, and scaling a production environment to run web applications. It automatically handles the provisioning and deployment of necessary AWS resources, such as EC2 instances, auto-scaling groups, RDS database instances, and elastic load balancers. Once your application is up and running, you can continue to support and maintain the environment just as you would with a custom-built environment outside of Elastic Beanstalk. It supports a variety of platforms and programming languages, including containerized applications using Docker, making it a flexible service for DevOps. Elastic Beanstalk provides a simple, effective, and quick solution for deploying web applications, making it an ideal service for developers and engineers. The service itself is free to use, but you will be charged for any resources that Elastic Beanstalk creates on your application's behalf, such as EC2 instances and applications load balancers. Elastic Beanstalk application consists of environments, versions, and environment configurations, each with specific roles and functionalities. When creating a new environment, you must specify an environment tier based on your web application functionality, choosing between a web server environment tier and a worker environment tier. The process for deploying and managing an application using Elastic Beanstalk involves configuring an environment, specifying the environment tier, providing application information, and configuring network and database settings. Let's dive into the world of AWS Lambda. To truly grasp serverless compute, we must first understood the traditional server setup. Imagine the freedom of focusing solely on your code and business logic without the burden of infrastructure maintenance and administration. AWS Lambda functions consist of three key parts: the input, the function itself, and the output. Your function represents your business logic and can be configured with important details like permissions and compute power. With AWS Lambda, you have the flexibility to choose from a variety of runtimes, including Java, Go, PowerShell, Node.js, C Sharp, Python, and Ruby. Custom runtime support is also available for languages not natively supported. Your Lambda function can be invoked through various methods such as the console, SDK, HTTP endpoints, or triggers from other AWS services. Once triggered, your function can make calls to downstream resources like DynamoDB and SNS. When it comes to cost, you'll only pay for the resources you use based on the number of requests, duration of code execution, and the allocation compute power. AWS Lambda offers a seamless, cost-effective solution for running your application code. Embrace the power of serverless compute with AWS Lambda. AWS Batch. AWS Batch is designed to handle batch computing workloads that require a large amount of compute power spread across a cluster of resources. It's ideal for tasks like training machine learning models and conducting large scale data analysis. With AWS Batch, you can seamlessly create a cluster of compute resources that's highly scalable and takes advantage of the elasticity of AWS. AWS handles all the provisioning, monitoring, maintenance, and management of your clusters, saving your time and resources. AWS Batch consists of jobs, job definition, job queues, and compute environments. These components work together to define, schedule, and execute batch computing workloads efficiently. That's a quick overview of AWS Batch. Thank you for joining us and best of luck with your continued learning. Amazon Light Sail. Amazon Light Sail is a virtual private server or VPS backed by AWS infrastructure designed to be simple, quick, and very easy to use at a low price point for small scale use cases. You can run multiple Light Sail instances together, connect it to other AWS resources, and access it either via the AWS console or directly to the Lightsail homepage. To create a new instance, simply select your region, platform, blueprint, launch script, key pair, and instant plan. It's that simple. Once your instance is up and running, you have a number of management and monitoring options, including connect, metrics, snapshots, storage, networking, domains, tags, history, and delete. Amazon Lightsail provides lightweight, cost-effective solution for small projects and use cases. So thanks for joining us for this quick introduction to Amazon Lightsail. So let's carry on. So AWS Outpost. This service is designed to bring the capabilities of the AWS cloud to your on-premises data center, offering a consistent hybrid cloud experience. Organizations may choose to adopt a hybrid cloud approach due to reasons such as latency, security, and governance requirements. Outposts allow you to run AWS services such as ECS, EKS, S3, RDS, and EMR on premises. It also supports EC2 with a wide range of instance types available, as well as migration and disaster recovery scenarios that leverage cloud and Cure. Additionally, Outpost supports VMware Cloud on AWS, creating a secure, flexible, and scalable hybrid cloud infrastructure model for your organization. You can order Outpost through the AWS Management Console, selecting from different compute and storage options. It's important to note that to place an order, you must have either an enterprise or enterprise on-ramp support plan with AWS. And because AWS Outposts are fully managed, you do not need to maintain a level of patch management across your infrastructure or worry about installing or updating any software. So let's dive into AWS Elastic Load Balancer service, what it is and how it works. The main function of an Elastic Load Balancer or ELB is to evenly distribute inbound requests across a group of targets such as EC2 instances, Lambda functions, IP addresses, or containers. Using a single instance for your application can lead to challenges like downtime and performance limitations. An ELB helps by evenly distributing traffic across multiple instances, provide high availability and automatic scaling. So there are three types of ELBs to choose from: the application load balancer, the network load balancer, and the classic load balancer, each of its own unique features and use cases. So the key components are listeners, target groups, rules, and health checks are essential components of an ELB, ensuring efficient routing and maintaining the health of the resources. Overview of server certificates and ALB listeners. The application load balancer provides a flexible feature set for web applications running the HTTP or HTTPS protocols. When using the HTTPS encrypted protocol as a listener, it requires additional configuration to set up an encrypted communication channel between clients and your application load balancer. To receive encrypted traffic over HTTPS, your ALB will need a server certificate and an associated security policy. These certificates are X509 certificates, provisioned by a certificate authority such as the AWS Certificate Manager Service (ACM). When selecting HTTPS as your listener, you will be asked to choose a certificate from ACM, upload a certificate to ACM, choose a certificate from IAM, or upload a certificate to IAM. Using ACM simplifies the configuration process and is the preferred option. So let's understand the application load balancer in AWS. The ALB operates at layer 7, the application layer on the OSI model, providing advanced routing and visibility features for application architectures like microservices and containers. Before setting up your ALB, it's essential to configure target groups. These groups route requests to different resources based on the nature of the request. In the AWS Management Console, navigate to the EC2 service, select Load Balancing, then Target Groups, and create a new target group. Specify the target type, protocol, VPC, and health check settings. After creating the target group, associate the relevant instances with it. These ensure that the ALB routes request to the specified resources. With the ALB, you can easily create different target groups and customize how your load balancer directs traffic based on your specific rules. Let's dive into network load balancer and its configuration. The network load balancer operates at layer 4 on the OSI model, enabling you to balance requests purely based on the TCP and UDP protocols. It can process millions of requests per second, making it a great choice for ultra high performance applications. Also, if your application logic requires a static IP address, then the NLB will need to be your choice of elastic load balancer. Now let's provide a demonstration on how to configure and set up a network load balancer. To create our network load balancer, let's go to EC2 under compute, then under load balancing, click load balancers and then click on create load balancer. Select the UDP protocol and the load balancer port, configure security settings, routing and associate the target group. Once you are happy with all your configuration settings, click on create and there you have it. Your network load balancer is now created. So let's now dive into the overview of classic load balancer. The classic load balancer supports TCP, SSL TLS, HTTP and HTTPS protocols. It's best practice to use the ALB over the classic load balancer unless you have an existing application running on the EC2 classic network.
The EC2 Classic platform is no longer supported for newer AWS accounts created after April 12, 2013. Creating a classic load balancer involves selecting the VPC, configuring listener settings, assigning security groups, configuring health checks, and associating instances. The Classic Load Balancer offers supports for EC2 Classic, TCP, and SSL listeners and sticky sessions using application generated cookies.
Let's dive into the world of EC2 autoscaling. EC2 autoscaling is a mechanism that automatically adjusts your EC2 resources based on custom defined metrics and thresholds. It allows you to increase or decrease your EC2 fleet to meet demand, ensuring optimal performance and cost efficiency. Imagine having a single EC2 instance as a web server. As demand increases, so does the load on the instance. With autoscaling, you can configure metrics to automatically launch additional instances to balance the load, ensuring smooth performance for end users. Similarly, when demand decreases, autoscaling can automatically terminate unnecessary instances, optimizing cost. Autoscaling provides automation, greater customer satisfaction, and cost reduction. It elastically provisions resources, prevents performance issues, and optimizes resources cost based on demand. There are two key steps to the configuration process of EC2 autoscaling: creating the launch configuration or launch template and then creating the autoscaling group. So when using EC2 autoscaling, you can either create a launch configuration or a launch template. Both define how an autoscaling group builds new EC2 instances. The launch template is essentially a newer and more advanced version of the launch configuration, allowing you to simply how you launch instances for your autoscaling groups. To create a launch template, you will need to specify various parameters such as AMI ID, instance type, key pair, network type, security groups, storage volumes, instance tags, and more. Once you are happy with the information, simply click on Create Launch Template. Creating a launch configuration is similar to creating a launch template, but with a few differences in options and presentation. Once you're satisfied with the selected options, click on Create Launch Configuration. The main difference between the two is that the launch template is presented all on a single page, allowing you to quickly select your options without either the launch configuration or launch template. Autoscaling would not know what instance it was launching and to which configuration. So stay tuned for the next demonstration on how to create an autoscaling group. So let's dive into an overview of the relationship between ELBs and EC2 autoscaling. ELBs and EC2 autoscaling work hand in hand to optimize performance and cost efficiency. The ELB dynamically manages loads across resources based on target groups and roles, which EC2 autoscaling elastically scales those target groups based on infrastructure demand. Operating with just an ELB and an autoscaling means manually managing and monitoring demand, adding or removing instances as needed. On the other hand, having EC2 autoscaling without the ELB means unevenly distributing traffic to the EC2 fleet. So combining an ELB and autoscaling helps manage and automatically scale EC2 compute resources. When attached, the ELB will automatically detect instances and distribute traffic to the resources in the autoscaling group. To attach an existing load balancer to your autoscaling group, simply go to the EC2 dashboard, select the autoscaling group, go to the actions, then edit and add the classic load balancer or associated it with the relevant target group.
Combining ELBs and EC2 autoscaling is a quick and simple way to optimize your infrastructure. Storage in AWS. Designed to help you prepare for the AWS Cloud Practitioner certification. Whether you are new to cloud computing or looking to expand your knowledge, this lesson is tailored to guide you through the various stages services in AWS. So, introduce your storage services. Let's dive into the Amazon Simple Storage Service S3, Amazon Elastic Block Store EBS, Amazon Elastic File System EFS, and Amazon FSX. Additionally, we will explore hybrid cloud storage services and on-premises data backup solutions using AWS Backup, AWS Storage Gateway, and AWS Elastic Disaster Recovery. So let's start with the Amazon Simple Storage Service S3. So Amazon S3 is a fully managed object-based storage service provided by AWS. It's highly available, durable, cost-effective, and scalable. S3 offers unlimited storage capabilities and a durability of 99.999%, making data loss extremely rare. When uploading data, you specify the regional location, and S3 stores and duplicates your data across multiple availability zones within that region. So to store objects in S3, you first define and create a unique bucket, then upload your data within it. You can also create folders within the bucket for easier data management. Amazon S3 is a powerful and versatile storage service offering high durability, availability, and scalability for a wide range of use cases. So, Amazon S3 offers a range of storage classes, each designed to meet specific performance and cost requirements. So, let's dive into the different storage classes available and their unique features. So, the first one is S3 standard storage class. It's ideal for high throughput, low latency, and frequent data access. It offers 99.99% availability and 11 nines of durability across multiple availability zones. With SSL support for data encryption and lifecycle rules for automatic data management, it provides a secure and flexible storage solution. S3 Intelligent Tiering is perfect for unpredictable data access patterns, automatically optimizing storage costs. It offers the same durability as S3 storage and supports lifecycle rules, providing a cost-effective and efficient storage solution. S3 Glacier Deep Archive for long-term storage needs. S3 Glacier Deep Archive is the most cost-effective option, offering 11 nines in the durability and 99.9% availability. It's ideal for data retention, compliance, and minimal access requirements. When selecting a storage class for your data, consider factors like criticality, reproducibility, and access frequency. Choose the right storage class to meet your specific data requirements. EC2 instance to volumes. So let's dive in and understand the key points about these unique storage options. EC2 instance to volumes, a local disk drive physically resting on the same host as your EC2 instance. They provide ephemeral storage, meaning any data stored on these volumes is considered temporary and could be lost if instance is stopped or terminated. Despite the risk of data loss, instance store volumes have benefits. They're cost effective, offer high input output speeds, and are ideal for frequently changing data, making them great for catching and load balancing groups. So it is important to note that not all instance types support instance store volumes. Additionally, from a security standpoint, they don't offer additional security features and have the same security mechanism provided by EC2. If you need persistent data or shared access, EC2 instance store volumes may not be the best option. However, for a quick and easy block level storage, the Elastic Block Store service is recommended. So introduction to Amazon Elastic Block Store. So let's dive into the key features and benefits of EBS. EBS provides persistent and durable block level storage, offering flexibility in managing data compared to instance store volumes. EBS volumes can be attached to your EC2 instances and are used for rapidly changing data that may require a specific input output operations per second rate. EBS volumes are independent of the EC2 instance, ensuring data persistent even if instances are stopped, restarted, or terminated. EBS also offers point-in-time backups known as snapshots stored on Amazon S3, providing resilience and flexibility. So there are two types of EBS volumes, SSD-backed storage and HDD-backed storage, each with unique characteristics and performance factors. These volumes cater to different use cases, offering optimized storage solutions. EBS enhances data security through encryption using the AES 256 encryption algorithm, the interaction with the key management service for encryption process. Snapshots from encrypted volumes and volumes created from encrypted snapshots are also encrypted. In conclusion, EBS offers a range of benefits, including high availability, resilience, and security, making it a versatile storage option for EC2 instance. So let's check out Amazon Elastic File System or EFS. So Amazon EFS is a fully managed, highly available and durable service that provides simple scalable file storage for use with Amazon EC2 instance. It supports access by multiple EC2 instances at once, much like traditional file servers or network attached storage. EFS is designed to maintain a high level of throughput and low latency access, making it a desirable storage solution for a wide variety of workloads and use cases. It supports both NFS version 4.1 and 4.0 and uses standard file system semantics such as strong consistency and file lacking. The file system is replicated across availability zones in a single region, making EFS a highly reliable storage service. It's a great storage option for applications that scale across multiple instances, allowing for parallel access of data. In conclusion, Amazon EFS is a powerful and flexible storage solution that can easily scale to petabytes in size with low latency access, making it an ideal choice for a wide range of applications and workloads. So let's try to understand Amazon EFS storage class options and performance modes. Amazon EFS offers two different storage classes, standard and infrequent access. The standard storage class is the default storage used when using EFS, while IA is generally used for data that is rarely accessed, offering a cost reduction on your storage. So EFS provides two performance modes, general purpose and max input output. General purpose is typically used for most use cases, offering all-round performance and low latency file operation. Max input output, on the other hand, offers virtually unlimited throughput and IOPS, but the higher file operation latency. EFS also provides two different throughput modes, bursting throughput and provisioned throughput. Bursting throughput scales as your file system grows, while provisioned throughput allows you to burst above your allocated allowances based on your file system size. So let's dive into Amazon FSX, a dedicated file system that might be the solution you need. So when it comes to creating a file system with AWS, you might be considering Amazon EFS or Amazon FSX. So, but what's the difference? Amazon EFS is a simple and scalable file system for Linux-based workloads, while Amazon FSX offers two options, FSX for Windows File Server and FSX for Lustre. FSX for Windows File Server provides a highly scalable, fully managed file storage solution that is accessible over SMB protocol. It's perfect for various applications and workloads, including home directories, line of business applications, web servers, and more. With features like encryption, data duplication, and fast in memory caching, it's a robust solution for Windows based applications. On the other hand, FSX for Lustre is built for high performance computing, providing extremely fast file storage with up to 100 gigabytes per second of throughput. It's ideal for workloads like high performance compute, machine learning, and video processing. So, when designing your architectures around storage, it's critical to understand if your application is sensitive to throughput or IOPS. Whether you need solid state disk for low latency or hard disk drives for maximum throughput. Amazon FSx has the solution for your specific needs. And if your data is located on premises but you lack the necessary compute resources, Amazon FSx can help you seamlessly burst into the cloud for the additional service resources you need. With Amazon FSx, you can find the perfect file storage solution tailored to your specific use case. So explore the possibilities of FSx of your data storage needs. So let's dive into an overview of AWS Backup, a centralized solution for managing and implementing backups across various AWS services. So the key features are AWS Backups acts as a central hub to manage backups across your environment, providing full auditability and compliance controls. It also allows for the automation of on-premises data backup through AWS Storage Gateway. So what are backup plans? So when using AWS Backup, you will need to create backup plans, which includes backup schedules, Windows lifecycle rules, backup vaults, regional copies and tags. These plans can be customized to meet the backup needs of different types of resources. The service offers warm and cold storage options with cost based on GB per month. Implementing lifecycle rules for supported resources can help optimize backup cost. So AWS Backup provides a comprehensive solution for centralizing, monitoring, and optimizing backups across multiple regions. By leveraging backups plans and lifecycle rules, users can effectively manage backup cost and ensure data retention when needed. AWS Storage Gateway. The gateway can be deployed as a virtual machine, a hardware appliance, or in the AWS environment as an EC2 instance. Regardless of the deployment method, a minimum of 150 MB of local disk space is required for the local cache. There are four types of storage gateways: S3 file gateway, FSX file gateway, tape gateway, and volume gateway, each serving different storage needs. The pricing component includes storage pricing, request pricing, and data transfer pricing, which cost varying based on the type of gateway used. In summary, AWS Storage Gateway offers a flexible, cost-effective solution for a hybrid storage needs, enabling seamless communication between on-premises applications and storage class cloud storage services. So let's dive into introduction of AWS Elastic Disaster Recovery (DRS). So AWS Elastic Disaster Recovery is a service that enables you to recover from application failures in physical or virtual servers hosted in on-premises data centers or other cloud providers. It allows you to save cost by utilizing AWS resources in the cloud instead of maintaining an expensive physical disaster recovery site. With DRS, you only pay for your recovery site resources when they are in use, either during a drill or an actual failover. DRS automatically converts your physical servers to run natively on AWS in the event of a failure, making it possible to use DRS for migrating on-premises workloads and applications to the AWS cloud. It fully integrates with the AWS Management Console and supports integration with other AWS services, including IAM, CloudWatch, and CloudTrail. So thanks for joining for this quick introduction to AWS Elastic Disaster Recovery. Good luck on your certification journey. So let's dive into introduction to database services in AWS. So managed relational database using Amazon relational database servers or RDS, including Amazon Aurora. Managed NoSQL databases, including Amazon DynamoDB. So let's try to understand the AWS managed databases. So databases are the foundation of modern application development with two primary types, relational and non-relational. So there are 9 primary categories of database available on AWS, each optimized to support a specified type of workloads. So matching an application with the appropriate database type is essential for highly performant and cost-effective operation. So operational applications or OLTP are centered around regular repeatable business process, while analytical applications or OLAP are run on demand for things like business intelligence workloads and data analysis. Databases power 21st century applications, and the efficient use of resources in the cloud requires organizations to be agile, responsive to change, and consider the requirements of scalability and elasticity. That's a glimpse into the world of AWS managed databases. So let's dive into the world of relational databases. Relational databases have been around since 1970s, providing an efficient, intuitive, and flexible way to store and report on highly structured data. The structures, called schemas, are defined before any data can be entered into the database. So data in a relational database is stored in tables, with each table containing one or more rows of data. These tables have primary keys that uniquely identify the information stored in each row. Data integrity is of a particular concern in a relational database, with constraints ensuring the reliability and accuracy of the data. The standard user and application programming interface of relational databases is the structured query language SQL. It is used to create, update, and maintain the data inside a relational database. Scaling an application. Relational databases are ideal for applications that do online transactional processing, such as online banking, e commerce sites, and financial services. However, for analytical applications processing larger volumes of data, non relational databases, also known as NoSQL databases, are helpful. Relational databases offers a structured and reliable way to store and manage data, making them essential for a wide range of applications. So let's dive into the world of non-relational schemaless and horizontally scaled data stores and NoSQL databases. NoSQL databases are a family of non-relational databases that includes key value databases, column family stores, document stores, and graph stores. They also known for their flexibility and unstructured, rapidly changing data. The scaling a NoSQL database is easier and less expensive than scaling a relational database. NoSQL databases generally trade consistency for performance and scalability, making them a popular choice for developers. In summary, NoSQL database offers a dynamic approach to organize data, making them a great fit for applications with unstructured or semi-structured data. Whether it's a key value, document, or graph stores, NoSQL databases provides a wide range of options for developers. Amazon Relational Database Service (RDS). Amazon RDS, a managed service that simplifies the provisioning and scaling of relational databases within AWS. Amazon RDS offers a variety of database engine options, including MySQL, MariaDB, PostgreSQL, Amazon Aurora, Oracle, and SQL Server. Each engine is tailored to specific use cases and performances. providing flexibility and choice for your database needs. With Amazon RDS, you can streamline your database operations and focus on innovation. Stay tuned for more insights on optimizing your AWS environments. Amazon DynamoDB, a fully managed serverless NoSQL database service. Amazon DynamoDB is a fully managed, meaning AWS handles infrastructure provisioning and maintenance. No database administration, server provisioning, or backup complexity required. It, it's also serverless, so server administration is invisible to the user. AWS takes care of the servers, allowing you to focus solely on your data and its modeling. DynamoDB is a NoSQL database storing data differently than relational databases. It supports key value and document access patterns, providing highly partitionable and scalable key value stores. So experience the ease and power of Amazon DynamoDB for efficient data management and access. Let's dive into the key features and characteristics of DynamoDB. DynamoDB is designed to be highly available by default, with data automatically replicated across three different availability zones within a geographic region. These ensures resiliency in the case of an outage or incident. DynamoDB provides fast performance and has no upper limit to how large a table can scale to, making it ideal for OLTP workloads that need high scalability and data durability. The database supports transactions and offers global tables for even greater level of resiliency and performance, enabling data replications across regions for low latency reads and writes. DynamoDB offers backup functionality, including on-demand backup and point-in-time recovery, ensuring compliance, and the ability to roll back to a previous state. DynamoDB is best suited for OLTP workloads, especially for new serverless applications, and is commonly used in gaming, e-commerce, and transportation industries. If you require a fully managed OLTP database that is infinitely scaled and serverless, DynamoDB is a great choice. So let's try compare the DynamoDB to relational databases. Relational databases scale vertically while DynamoDB scales horizontally, allowing it to scale almost infinitely. This means that DynamoDB scales transparently to the user, handling scalability without the need for manual management. Unlike relational databases with fixed schemas, DynamoDB is schemaless. This means you don't have to define a fixed table structure in advance, allowing more flexibility in adjusting columns and data types on the fly. While DynamoDB offers scalability and flexibility, it has limitations. For instance, its query and scan feature aren't as flexible as SQL, and it has a limited range of data types compared to relational databases. So if you're familiar with NoSQL databases like MongoDB, you find the DynamoDB varies in terms of data modes, models, and platform compatibility. DynamoDB has a strict limitation such as maximum item size of 400 kilobytes, which may require storing large objects in a separate storage solution. Consider these factors when deciding between DynamoDB and relational databases. So let's check out Amazon Neptune, the fast, reliable, secure, and a fully managed graph database service. Amazon Neptune is ideal for various use cases such as social networking, fraud detection, and recommendation engines. It's a powerful asset for understanding and querying complex relationships within vast interconnected datasets. Amazon Neptune uses its own graph database engine and supports two graph query frameworks, Apache Tinkerpop, Kremlin, and World Wide Web Consortium SparkQL. Additionally, a Neptune database cluster is comprised of single or multiple database instances across different availability zones, ensuring high durability and reliability of data. Neptune storage auto repair automatically detects and repairs segment failures, minimizing data loss. Replica instances are used to scale read operations and provide failover support, ensuring minimal lag for read query results. Amazon Neptune provides three types of endpoints: cluster endpoint, reader endpoint, and instance endpoint, each serving different purpose for accessing the database. Now that you have a better understanding of Amazon Neptune, you can explore its capabilities and consider its potential applications in your solutions. Amazon Memory DB for Redis, a fully managed in-memory data store service that's compatible with the popular open source Redis data structures too. Amazon Memory DB for Redis is designed to provide ultra-fast, low-latency access to data stored in memory, offering microsecond read and single-digit millisecond write latencies. It gets deployed as a cluster within your VPC, with each cluster consisting of one or more nodes responsible for serving a single dataset. These nodes are partitioned into shards, each with a primary node and up to 5 read replica nodes, spread across availability zones to provide high availability. In addition to these features, MemoryDB for Ready supports clusters up to 500 nodes in size, transaction logs distributed across multiple availability zones, data tiering, encryption of data in transit and at rest, and snapshots for easy backup and restore of your MemoryDB cluster. In summary, Amazon MemoryDB for Redis offers ultra-fast access to in-memory data sets and can help you reduce the complexity and cost of managing data store infrastructure for your application. So, introduction to networking and content delivery services in AWS, including Amazon Virtual Private Cloud or VPC, configuring security groups and network access control list or NACL, AWS Private Virtual Private Network or VPN solutions, or AWS Direct Connect. So let's dive into the world of VPCs or virtual private clouds within the AWS infrastructure. A VPC is essentially your own isolated segment of the AWS cloud, providing a secure environment for deploying resources like compute, storage, databases, and networks infrastructure. So when you create a VPC, it's completely isolated, accessible only by your own AWS account. Each AWS account can have up to 5 VPCs per region, and creating one is as simple as defining a name and the IP address range using a CIDR block. In summary, a VPC is a secure space within the AWS public cloud, allowing you to provision and deploy resources safely. Stay tuned as we delve deeper into VPC architecture and discuss subnets and segmentation across multiple availability zones for resiliency and high availability. So let's try to understand subnets in AWS VPC. So subnets reside inside your VPC, allowing you to segment your VPC infrastructure into multiple different networks. These can create better resource management, isolate certain resources, or enhance high availability and resiliency within your infrastructure. So public subnets are accessible from outside the VPC, while private subnets are considered private and inaccessible by default from the internet. To make a subnet public, you need to add an internet gateway and configure the route table. This allows the subnet to access the internet. To ensure high availability and resilience, it's best to deploy resources across multiple availability zones. This way, if one zone experiences a failure, your services will remain up and running. By adding additional subnets and replicating resources, you can ensure that at least one subnet in each layer of your infrastructure remains operational. Now that we have covered subnets, let's move on to some security features. Managing security in AWS Virtual Private Cloud. So security is a crucial in any AWS deployment, and it's no different when it comes to your VPC. One key component is NACLs, or Network Access Control List. These access virtual network level firewall for each subnet, controlling both inbound and outbound traffic. By configuring NACLs, you can ensure that only the desired traffic is allowed in and out of your subnet. So for example, in a public subnet with web servers, you can set up inbound NACL rules to allow HTTP and HTTPS traffic while denying all other traffic. These ensures that only the necessary traffic is permitted. Similarly, outbound NACL rules restrict traffic based on its destination. They allow specific traffic to exit the subnet while denying all other traffic. So remember, NACLs are stateless, meaning response traffic must be explicitly allowed. They are a powerful tool for controlling traffic in and out for your subnets. Security groups and network access control lists, NACLs. These are crucial for filtering traffic and ensuring the security of your network. Security groups operates at the instance level, allowing you to control traffic to and from specific instances. They are more specific and flexible compared to NACLs, making them ideal for controlling access to databases and other resources. On the other hand, NACLs work at the subnet level, providing a broader control over traffic within the subnets. They are essential for filtering traffic at the network layer. Both NACLs and security groups work together to provide comprehensive security. NACLs control traffic at the subnet level, while security groups manage traffic at the instance level, ensuring a multi-layered approach to network security. By understanding the roles of NACLs and security groups, you can effectively control and secure the flow of traffic within your network. So let's try to understand the NAT gateway in AWS VPC. In an AWS VPC, a NAT gateway allows instances within a private subnet to access the internet while blocking all incoming initiations from the internet. This ensures the security of the private subnet and helps in maintaining the security of EC2 instances. The NAT gateway sits within the public subnet, has a public IP address, and is managed by AWS. It's easy to set up and configure, and AWS will manage all other configurations. If you have multiple public subnets in different availability zones, you will need to set up another NAT gateway within each subnet. In summary, a NAT gateway is a crucial component in AWS VPC, providing secure internet access to private subnets while maintaining the security of EC2 instances. So let's dive into the world of VPN connections, also known as virtual private networks. A virtual private network is a secure way of connecting two remote networks across the internet. In the context of AWS and VPC, it's a powerful tool for enabling secure communications between resources in a private subnet and on-premises data centers. To set up a VPN, you will need to create a virtual gateway in your VPC and a customer gateway in your data center. Then you will initiate a tunnel between the two endpoints and configure the route table associated with the private subnet. Now let's talk about direct connect. Unlike VPN, direct connect doesn't use the internet. It's a method of connecting your remote location directly to AWS environment using a private infrastructure. So whether it's setting up a secure VPN connection or exploring the benefits of direct connect, there are multiple options for connecting your own premises data center to your AWS environment. So let's try to understand AWS Direct Connect. This is a method of connecting your remote location like a data center or remote office to your AWS environment. It's different from a VPC connection because it doesn't use a public internet. Instead, it uses private infrastructure to connect directly to your VPC. With Direct Connect, there is a middle entity, usually an AWS partner or customer, that holds the infrastructure. These includes a customer side and an AWS side, both within a facility owned and managed by a partner of AWS. The connection is made to a defined AWS region, not just a VPC, allowing access to public and private resources. You can configure private and public virtual interfaces on your router. The private interface connects to your VPC, while the public interface allows access to public AWS resources. These all happens without traversing the public internet using dedicated and isolated infrastructure. Direct Connect offers a private connection with speeds from 1 to 10 gigabytes per second, making it a reliable and high speed option for connecting your remote location to your AWS environment. So that's a high level overview of AWS Direct Connect. Stay tuned for more insights on VPC peering and the transit gateway. Understanding VPC pairing in AWS. VPC pairing allows you to connect two VPCs together, enabling communication between resources in each VPC, whether they are in the same region or different regions. It's important to note that VPC pairing is one-to-one connection only, meaning each VPC can only be directly connected to one other VPC. With setting up VPC pairing, ensure that the IP addressing schemas of the VPCs do not overlap, as these would prevent the pairing connection. To initiate a pairing connection, the owner of one PPC sends a pairing request to the owner of the other PPC. Once accepted, both VPCs update their routing tables to allow traffic to flow between them. And that's a brief overview of VPC pairing in AWS. Stay tuned for more insights. So let's jump into the overview of AWS Transit Gateway. It's a central hub that simplifies network connectivity, allowing all your VPCs and remote locations to communicate with each other easily. With AWS Transit Gateway, you can connect all your VPCs and remote locations through a central hub, reducing the complexity of managing multiple connections. This centralization allows for easier monitoring of network traffic and connectivity through a single dashboard. In summary, AWS Transit Gateway streamlines your network infrastructure, making it easier for VPCs and remote locations to communicate. So say goodbye to hassle of managing numerous VPC pairing connections and embrace the simplicity of AWS Transit Gateway. So let's dive into the world of domain naming system and how Route 53 provides secure and reliable routing of request. So what is DNS? DNS or domain name system is like the phone book of the internet, translating domain names to IP addresses. It's a crucial part of how the internet functions. Route 53 is Amazon's highly available and scalable domain name system, offering secure and reliable routing of requests. It's managed through a global network of authoritative DNS servers, reducing latency and providing secure routing. Route 53 includes components like hosted zones, supported domains, resource record types, and routing policies, each playing a vital role in managing and routing traffic effectively. With its robust features and global network, Amazon Route 53 is a powerful tool for managing DNS and routing traffic. So let's try to explore how Amazon CloudFront works and its key features. Amazon CloudFront is a content delivery network service provided by AWS. It's designed to speed up the distribution of your static and dynamic content through a network of edge locations worldwide. When a user requests content, CloudFront routes the request to the closest edge location, reducing latency and delivering the best performance through cached data. CloudFront uses distribution to control which source data it needs to redistribute and to where. It offers two delivery methods: web distribution for static and dynamic content, and RTMP distribution for streaming media. So when configuring your distributions, you will need to enter your origin information, selecting caching behavior options, and define the distribution settings. Once your distribution is configured, you simply enable it for it to be created. These allow end users to access content from their closest edge location, reducing latency and improving performance. And that's a brief overview of Amazon CloudFront. Stay tuned for more insights on AWS services. So let's explore how these AWS Global Accelerator can enhance the speed, reliability, and security of your application. The AWS Global Accelerator efficiently routes UDP and TCP traffic from end user clients to applications, leveraging AWS global infrastructure and specified endpoints. These ensures faster, more reliable connectivity compared to traversing the public internet. To set up the AWS Global Accelerator, follow four key steps: creating the accelerator, setting up a listener, associating it with an endpoint group, and finally registering your endpoints for the application. So let's take a quick look at how to create an AWS Global Accelerator in an AWS Management Console. First, select a name for your accelerator and choose the IP address type. Then add listeners for incoming connection and configure endpoint groups for different regions. With AWS Global Accelerator, you can easily enhance the performance and availability of your application across multiple regions. So let's dive into introduction of migration and transfer services in AWS, which includes the AWS Cloud Adoption Framework, AWS Application Discovery Service, AWS Application Migration Service, AWS Database Migration Service or DMS, AWS Migration Hub, AWS Schema Conversion Tool, AWS No Family, AWS Transfer Family. So let's dive into the world of AWS Cloud Adoption Framework. The AWS CAF accelerates digital transformation to the AWS cloud, offering benefits like reduced business risk and improved operational efficiency. It focuses on six perspectives: business, people, governance, platform, security, and operations, aligning with foundational capabilities across four transformation domains. So, for example, within the business perspective are foundational capabilities like strategy management and product management. These perspectives, transformation domains, and foundational capabilities provide a roadmap for outcomes like reduced business risk and increased operational efficiency. The AWS CAF encourages incremental and iterative transformation consisting of phases like envision, align, launch, and scale. So, if you're looking to accelerate your digital transformation to the AWS cloud, the AWS Cloud Adoption Framework is your guide to success. The 7 R's. Curious about the 7 R's and why they exist? They are a framework designed to guide organizations through migrating from on premises infrastructure to the public cloud like AWS. Whether you're moving a whole data center or just one application to AWS, the 7 R's help evaluate the most efficient migration strategy that aligns with your business requirements. Migrating to the cloud involves addressing all components, not just the application itself. These includes customer data, communication, security, and ongoing management. So what are the 7 R's? They are rehosting, replatforming, repurchasing, refactoring, re-architecting, relocating, retiring, and retaining. These methods help focus on the most appropriate approach based on your specific needs. So let's dive into a Snow family in AWS, a range of physical hardware devices designed to transfer data. A Snow family consists of various physical hardware devices that enable the transfer of data into AWS from the edge or beyond the cloud, such as your data center. These devices can also be used to transfer data out of AWS, for example, from Amazon S3 back to your data center. You can perform data transfers from as little as few terabytes using an AWS Snow Cone all the way up to a staggering 100 petabytes using a single AWS Snow Mobile. These devices are essential when traditional network connectivity is not feasible due to time constraints and data transfer fees. In addition to these storage capacity, some Snow family devices come with compute power, allowing you to run usable EC2 instances designed for the Snow family. These enables applications to run operations in remote and difficult to reach environments even without a data center in sight. The Snow family is revolutionizing data transfer, making it possible to process and analyze data closer to the source, even in challenging environments. AWS Snow family, the future of data transfer. So let's compare the AWS Snow Cone, Snowball, and Snowmobile to help you make an informed decision. The AWS Snow Cone is lightweight, portable, and rugged with 8 terabyte of storage and an EC2 instance. It's perfect for capturing, processing, and analyzing data, even in challenging environments. Plus, it can be attached to a drone for added versatility. The AWS Snowball is larger with up to 80 terabyte of storage and is ideal for large scale data transfer operations. It comes in different variants for storage, compute, and GPU acceleration, making it suitable for various use cases. You would use the Snow Cone for portable, on the go data needs, while Snowball is better suited for stationary, high capacity data transfer and compute intensive workloads. So, both the Snow Cone and Snowball are perfect for portable edge computing, data storage, and transfer in remote locations, industrial settings, and the media and entertainment industry. The AWS Snow Mobile is designed for massive data transfers up to 100 petabytes per unit, making it ideal for migrating entire data centers or storage libraries quickly, securely, and cost effectively. Now that you have a better understanding of the AWS Snow devices, you can confidently choose the right one for your specific needs. Let's dive into the introduction of AWS Transfer Family. The AWS Transfer Family is a fully managed service that allows secure file transfer into and out of AWS storage without the need to manage your own file transfer infrastructure. It supports protocols like FTP, FTPS, SFTP, and AS2, making it ideal for recurring or ad hoc business to business file transfers. Plus, it offers managed workflows for post upload processing tasks. For pricing, you will pay an hourly rate for each protocol enabled, along with a fixed per gigabyte rate for FTP, FTPS, and SFTP endpoints, and a fixed per message rate for AS2 endpoints. Decoupled architecture. In the past, applications were tightly coupled, with changes in one area easily disrupting other services. Decoupled architecture, however, allows different components to operate independently without being closely tied to each other. This means that changes to one component won't affect the other, allowing for faster and more efficient development. In event driven architectures, services are triggered by events that occur within the infrastructure. Events can be changes of state, like an EC2 instance transitioning from running or stopping. When implementing event driven architectures in AWS, there are typically three components: a producer, an event router, and consumers. The event router sits between the producers and consumers, ensuring that each component is decoupled and can operate independently.
Amazon Simple Notification Service or SNS. SNS implements a one-to-many message distribution model, allowing a single message to be published to a topic and then pushed to one or more subscribers. It can send push notification messages to mobile devices and desktops using various supported push notification services, including Apple Push Notification Service, Windows Push Notification Service, and more. Subscribers can be HTTPS URL endpoints, email addresses, AWS Lambda functions, or even text messages to phone numbers via short message services for clients in over 200 countries. SNS enables topic subscribers to selectively receive only a subset of the messages that interest them using a subscription filter policy in JSON format. With the ability to seamlessly scale from a handful of messages per day to millions of messages, Amazon SNS is the go-to service for implementing notifications using AWS services, including events. Amazon Kinesis data streams. So, are you curious about real-time data processing and its impact on modern applications? So, let's dive into the world of Amazon Kinesis data streams and its roles in handling large data sets in real time. So, real-time computing is crucial for applications like the stock market and Internet of Things devices, where data transfers and processing must be completed quickly for meaningful results. Amazon Kinesis Data Streams is designed to handle large data sets in real time, maintaining a copy of all received data for up to 365 days. It's made up of shards, each storing data records in sequence and can handle up to 1000 records per second per shard. The Kinesis client library ensures efficient and decoupled consumptions of record from the stream, simplifying the reading of data and enabling multiple consumer applications. In short, Amazon Kinesis data streams is a powerful tool for real-time processing of streaming big data, offering the ability to replay records of multiple applications ready to explore the world of real-time data processing. So try Amazon Kinesis data streams today and explore its benefits. So let's dive into the world of serverless computing within AWS. So let's explore the different categories and services available to help you navigate these existing domains. So first up, we have the serverless compute services. These are essential for any application handling the actual work performed. AWS Lambda, the pioneer in this space, allow you to run code without managing a server, while Fargate enables running serverless containers for an unlimited time. Moving on to application integration services, we have Amazon Event Bridge, AWS Step Functions, Amazon SQS, and Amazon SNS. These services act as the industrial glue connecting and sending data between applications and AWS services. Lastly, let's explore the serverless database services. Amazon S3, Amazon DynamoDB, Amazon RTS Proxy, and Aurora Serverless offers fully managed, scalable, and highly available data storage solutions. So whether you are delving into compute integration or database, AWS has a wide array of serverless options to suit your needs. So ready to embark on your serverless journey. So let's do an introduction to management and governance services in AWS, which includes AWS Cloud Trial, AWS Config, Amazon CloudWatch. So let's dive into the world of AWS Cloud Trial. AWS Cloud Trial is a service designed to record and track events, including API request and non-API request made within your AWS account. These events can be initiated from various sources such as user SDKs and AWS command line interface or even other AWS services. CloudTrail categorizes and tracks three types of events: management events, data events, and CloudTrail insight events, each providing valuable information about different aspects of your AWS resources and operations.
So by default, Cloud Trial is enabled for all new accounts, allowing you to view and filter events using the event history within the AWS Management Console. You can also configure Cloud Trial trails to store, review, and analyze captured events, providing deeper insights and enabling event-driven architecture. AWS Cloud Trial offers a powerful way to capture, store, and analyze events within your AWS accounts, providing valuable visibility and control over your infrastructure. AWS Config Service. Let's dive into what it is and what it does. So, in any organization, managing IT infrastructure resources can be a headache. So understanding what resources are available, their configurations, and security vulnerability is crucial. AWS Config was designed to capture resource changes, provide a resource inventory, store configuration history, and enable notification of changes. It can enforce rules for resource compliance, perform security analysis, and provide relationship connectivity information between resources. AWS Config is region specific and supports a wide range of common services and resources. So let's dive into Amazon CloudWatch, your window into the health and operational performance of your application and infrastructure. Amazon CloudWatch is a global service designed to monitor and review the performance of your resources, providing insights that can trigger automated responses or manual operational changes. CloudWatch offers a wide range of components, including CloudWatch dashboards, metrics and anomaly detection, alarm event bridge, logs, and insights. Using the AWS Management Console, you can build and customize dashboards with different visual widgets, offering a unified view of your resources. Metrics are fundamental to CloudWatch, enabling you to monitor specific elements of applications or resources over time, while anomaly detection helps detect abnormal activity. CloudWatch Alarm allow you to implement automatic actions based on specific thresholds, while Event Bridge provides real-time monitoring and event-driven architecture. CloudWatch Logs centralizes log data from various AWS services, and Insights provide the ability to analyze and visualize log data, container metrics, and Lambda metrics. Amazon CloudWatch offers a powerful suite of tools to help you gain valuable insights and optimize your infrastructure. So, AWS organization and service control policies. Let's explore the fundamental concepts of AWS organization and the benefits it brings to managing your AWS environment. As business expands their footprints on AWS, the need for multiple AWS accounts becomes apparent. These multi-account strategy is beneficial for reasons such as co-opt optimization, security governance, and workload management. AWS organization uses components like organizations, root, organizational units, accounts, and service control policies to help manage your accounts effectively. The primary benefit of AWS organization is its ability to centrally manage multiple accounts from a single AWS account known as the master account. It also provides greater control over your AWS environments and allow for consolidated billing and categorization of accounts. Stay tuned as we delve deeper into the hierarchy of AWS organization and the role of service control policies. Setup and configuration of AWS organizations. This process is crucial for managing multiple AWS accounts efficiently and securely. To begin, select a standard AWS account to serve as the master account. Remember, it's a best practice to use this account solely for managing the organization. Once the master account is chosen, you can create the organization. You have the option to enable all features or only consolidate billing depending on your needs. After creating the organization, the master account can invite other AWS accounts to join. The invited accounts will receive an email requesting their participation.
Finally, you can organize accounts into different organizational units for better management. These allows you to apply specific policies to different parts of your organization. Setting up and configuring AWS organization is a straightforward process that streamlines the management of multiple AWS accounts. Start by selecting a master account and creating the organization, then invite member accounts and organize them into units of efficient management. Service control policies in AWS organization. Let's explore how SCPs can be used to secure your AWS organization. Service control policies or SCPs set a boundary of permissions for AWS accounts. Unlike identity-based and resource-based policies, SCPs do not grant permissions themselves. Instead, they restrict permissions within an AWS account. For example, if an SCP denies access to the S3 device, S3 service, a user with full access to S3 via an identity-based policy would only be able to access RDS and EC2, despite having full access to S3. To use SCPs, you need to enable them from the root account of your organization. Once enabled, you can begin using SCPs within your organizations to manage security at an account level. SCPs do not affect resources based policies and only affect principles managed by your accounts in your organization. Understanding SCPs is crucial for securing your AWS organization. AWS Control Tower. Let's explore a simpler and more powerful way to create, govern, and administer large number of user accounts within AWS. AWS Control Tower is a service that offers a larger and more controlled method of creating, distributing, managing, and auditing multiple accounts. It simplifies the process of setting up a multi-account architecture that follows security and compliance best practices. The concept of a landing zone is crucial. It's a multi-account architecture based on a well-architectured framework focusing on security and compliance best practices. AWS Control Tower automatically creates a landing zone using best practices blueprints, setting up systems for identity, federation access, and overall account structure. AWS Control Tower also deploys guardrails, high-level security rules that provide continual oversight and help govern your accounts, users, groups, and resources. There are three types of guardrails: mandatory, strongly recommended, and elective, each designed to enforce best practices and security measures. With AWS Control Tower, you can simplify the management of user accounts, ensure compliance, and enhance security within your AWS environment. AWS Service Catalog. AWS Service Catalog is an organizational tool designed to simplify the provisioning and creation of IT stacks for both end users and IT admins. It allows users to select pre-approved services, reducing barriers to content creation and ensuring best practices and security system. Products are the heart of the AWS Service Catalog. They can range from a single AWS resource to a complex multi-tiered web application. Creating a product is simple. Just upload AWS Cloud Formation templates. Portfolios are collections of products with configuration information, and they can be customized for different users within your organization. Constraints allow you to control the scope and ability of your products based on predefined settings. Service actions enable end users to perform their own operational tasks, such as troubleshooting or running service level commands. And when it comes to pricing, there's a free tier that allows up to 1000 API calls per month at no charge. With AWS Service Catalog, you have full control over what your end users have to access to, maintaining high levels of security and credibility. So let's explore cloud security in AWS. AWS is responsible for the security of the cloud, including global infrastructure elements like region, availability zones, and edge locations, as well as the foundations of compute, storage, database, and network services. So once the data is put into the cloud, the responsibility shifts to the customer. It includes encryption, network traffic protection, operating system security, firewall configuration, application security, and identity and access management. It's crucial to tighten security to minimize exposure to external threats. The level of additional security you implement in your decision depending on the nature of your business and existing controls in place. Remember, while AWS provides powerful security controls, how often and when to apply them is not AWS responsibility. The AWS shared responsibility model dictates which security controls are AWS responsibility and which are yours. In short, you decide how you want your resources to sit in the cloud while AWS guarantees the global security of the cloud. Security is AWS number one priority. It's an area into which AWS pours huge capital and energy and devotes near constant attention. AWS is certified and compliant across a huge range of security standards, including PCI, DSS, ISO, and SOC. To help provide a clear definition of the boundaries of responsibility, AWS has advised three main models, each representing where AWS and customer responsibilities start and end. Shared responsibility model for infrastructure services, container services, and abstract services. Understanding the AWS shared responsibility model is a crucial for building and maintaining a highly secure and reliable environment on the AWS cloud. Shared responsibility model infrastructure services. So now here you can see some customer responsibilities and AWS responsibilities. So you can pause the video to have a look at this image. So let's dive into introduction to security, identity, and compliance services in AWS, which includes finding compliance data with AWS Artifact, managing users, groups, and roles with AWS Identity and Access Management or IAM, evaluating the security of your AWS environment using AWS Trusted Advisor. So AWS Artifact, the self-service portal that provides immediate access to AWS security and compliance reports. To access AWS Artifact, simply search Artifact in the AWS console. From there, you can view reports and agreements. AWS Artifact reports includes ISO certifications, PSI, and SOC reports, which are crucial for providing evidence of AWS security controls for compliance with governance, regulations, and frameworks. Remember, AWS is responsible for the underlying security of the cloud while you remain responsible for your systems and applications security in the cloud. In addition to reports, AWS Artifact allows you to view and execute legally binding agreements such as the AWS Business Associate addendum for storing personal health information. By using AWS Artifact, you can ensure that the solutions you architect in AWS Cloud remain secure and compliant with all necessary rules and regulations. Access AWS artifacts today to stay on top of your security and compliance needs. So let's dive into what Identity and Access Management IAM services actually means and how it's crucial for securing your AWS accounts. IAM involves two key stages: identity management and access management. Identity management is about defining how you are and verifying your identity. For example, your AWS username serves as your unique identity within IAM. Access management, on the other hand, focuses on authorization and access control. It determines what resources and identity can access within your AWS account. These includes permissions for specific AWS resources such as EC2 or RDS. IAM utilizes various authentication methods, including username and password, multi-factor authentication, and federated access. These mechanisms ensure secure access to AWS resources without compromising on identity verification. In essence, IAM empowers you to manage, control, and govern authentication, authorization, and access control mechanism within your AWS account. Understanding these security controls is vital for designing the right level of security for your infrastructure. Features and components of AWS IAM. Let's dive into the key aspects of these crucial service. So when accessing the IAM service through the AWS Management Control, you will be greeted with the IAM dashboard. Here you can customize a sign-in link for users, view a summary of your IAM resources, and access a list of IAM security best practices recommended by AWS. Under access management, we have components like users, user groups, roles, and policies. User represents identities and user groups are used to authorize access to resources. Roles allow temporary permissions and policies. Written as JSON documents, define access rules. If you're looking to provide federated access, you can add an identity provider. Additionally, under account settings, you can enforce a password policy and configure the security token service for temporary credentials. Moving on to access reports, the access analyzer helps identifying external access to your resources, while the credential report provides a comprehensive overview of IAM users and their credentials. Understanding these features and components is crucial for maintaining robust security within your AWS account. AWS IAM User Console Dashboard. Let's dive into the key features and functionalities of this powerful tool. When you open the AWS IAM dashboard and select users, you will find a summary of key points of interest relating to your IAM users. These includes last activity, MFA status, password age, console access, and more. The dashboard provides detailed information such as the user's path, groups they belong to, last activity, MFA status, password age, console access, and more. These allow you to easily manage and monitor user accounts. You can also view and manage access keys, including the age, last used, and associated ARN. These helps ensure secure programmatic access to your AWS resources. In conclusion, the AWS IAM User Console dashboard provides comprehensive insights and controls for managing user identities and access within your AWS environment. AWS Management Console, where creating a new user is a simple process. Let's dive into the steps to configure a new user. First, set the username up to 64 characters in length and select the AWS access type, either AWS Management Console Access or Programmatic Access. For programmatic access, an access key ID and secret access key ID will be issued. If console access is required, define a console password for the user. You can attach permission policies to the user or inherit them from a group. Permission boundaries can also be applied to control the user's maximum permission level. Review and confirm the information submitted before creating the user. Once the user is created, download the security credentials via a CSV file containing the username, access keys, and console login link. Creating a new user in the AWS Management Console is quick and straightforward. IAM user configuration and security options. Let's dive into the additional features available for IAM users. In the IAM dashboard, we can view a user's details such as their ARN and creation time. We can also explore different tabs, starting with the Permissions tab, which displays the policies the user is getting permissions from. We can set the user's permissions boundary, generate policies based on the cloud trial events, and add an inline policy for the user. Additionally, we can review the groups the user belongs to, manage tags, and handle security credentials, including setting up MFA and managing access keys. The Access Advisor feature allows to review the services the user can access based on their permissions and the last time these services were accessed. This is crucial for ensuring users have the appropriate access. These are just a few key points to consider when configuring IAM user properties. Stay tuned for more insights on user management and security options. IAM user groups, a powerful feature that simplifies access management at scale. IAM user groups are objects that contain IAM users and have IAM policies associated with them. These policies can be AWS managed, customer managed, or inline policies, allowing you to authorize access for members of the group to AWS resources. By applying permissions to a group instead of individual users, it becomes easy to modify permissions for multiple users at once, simplifying access management at scale. This is a security best practices that prevents the need to update permissions for each individual user. Creating a group is a simple three-step process. Give the group a meaningful name, add users to the group, and attach permissions via policies. Once created, you can easily review its configurations, edit permissions, and see their details. IAM user groups are a game changer for managing multiple users in your AWS account. They streamline access management, reduce the risk of human error, and make it easy to modify permissions at scale. IAM roles work in AWS. Let's dive in and find out how they allow trusted users, AWS services, and applications to adopt a set of temporary IAM credentials to access your AWS resources. IAM roles act as identities, much like users do, and have permissions assigned to them, defining what resources the roles can and can't access. Unlike users, IAM roles are designed to be assumed by multiple different entities as and when required. Roles are used for temporary access to gain access to resources, and each time the role is assumed by a user, an AWS service, or an application, a new set of credentials is dynamically created for the duration of that session. IAM roles are generally used to grant temporary access for users to AWS resources that they don't normally require access to grant access for an IAM user in one account to access resources in another account, or for an AWS service or an application that requires access to resources. Roles can be assumed by a user in the same AWS account, a user in a different AWS account, an AWS service such as EC2, or an external federated user to your AWS account. So, IAM roles provide a secure and flexible way to manage access to your AWS resources. So, ready to give it a try? So, let's dive into AWS IAM policy types. So, let's explore the four main policy types within AWS IAM and clarify their distinct functions. Let's start with identity-based policies. These policies are attached to users, user groups, or roles, controlling their permissions. They can be managed or inline policies, offering flexibility in permission management. Moving on to resource-based policies, unlike identity-based policies, these are associated with resources such as S3 buckets or IAM roles, defining access to the resource level. The next is we have permission boundaries. These policies set the maximum level of permission for a user or role, acting as a guide rail to limit access. Lastly, we'll discuss service control policies. So SCPs are used at the AWS account level to define maximum permissions for all members, providing an additional layer of security. So by understanding these policy types, you can effectively manage permissions within your AWS environment. Let's dive into AWS Key Management Service, KMS, the essential tool for securing your data in the AWS environment. KMS is the backbone of encryption for AWS services, ensuring the security of your data at rest. It provides the means to generate and manage encryption keys, enabling you to protect your data across various AWS services. KMS is built on various key components, including AWS managed, customer managed, and data keys, each serving a specific purpose in the encryption process. KMS seamlessly integrates with AWS Cloud Trail, allowing you to track and audit the usage of your encryption keys, ensuring compliance and governance within your organization. In summary, KMS is the cornerstone of data security in AWS, providing the necessary tool to encrypt your data at rest and remain compliant with your organization. AWS Trusted Advisor, your go-to tool for optimizing your AWS infrastructure. Let's explore the key components and benefits of these powerful service. AWS Trusted Advisor is a service that provides recommendations to optimize your AWS environment based on the best practices. It covers five categories: cost optimization, performance, security, fault tolerance, and service limits. Trusted Advisor offers over 115 different checks constantly updated to ensure the most accurate recommendations. It's important to note that access to these checks depends on your support plan with AWS. With a business and enterprise support plan, you gain access to a wealth of additional checks and features, including the ability to track changes, use the AWS Support API, and integrate with Amazon CloudWatch. Even without the premium support plans, everyone can benefit from features like Trusted Advisor notifications, exclude items, action links, and access management. Whether you're looking to save cost, enhance performance, or bolster security, AWS Trusted Advisor is an indispensable tool for optimizing your AWS environment. AWS WF service. If you're delivering web content through CloudFront distributions, Amazon API Gateway, REST APIs, application load balancers, or AWS AppSync GraphQL APIs, implementing the AWS Web Application Firewall service is crucial for an additional layer of security. Without a web application firewall, your websites and web apps could be exposed to harmful traffic, leading to potential security risks with significant financial and reputational impacts. The AWS Web Application Firewall helps prevent malicious attacks by common web attacks pattern, including those outlined in the OWASP top 10 list, such as SQL injection and cross-site scripting. In addition to custom criteria such as filtering requests based on source IP address or country of origin, AWS WF interacts with Amazon API Gateway, Amazon CloudFront, Application Load Balancer, and AWS AppSync to filter both HTTP and HTTPS requests, distinguish between legitimate and harmful inbound requests. The essential components of AWS WF include Web ACLs, rules, and rule groups. Web ACLs are associated with supported resources to determine safe web requests, while rules contain specific controls and criteria checks. Rule groups, on the other hand, are a collection of rules that can be applied to different web ACLs as needed. By implementing AWS WF, you can mitigate vulnerability risks and protect your web application architecture with a quicker, simpler, and more manageable solution. So if you're ready to enhance the security of your web application, let's dive into the world of AWS WAF. So overview of AWS Firewall Manager. If you're responsible for security across multiple AWS accounts, AWS Firewall Manager is a powerful tool to simplify your management and protection efforts. This service provides security protection for various resources across different AWS accounts, making it a crucial asset for organizations with complex infrastructure. AWS Firewall Manager integrates with AWS WAF, AWS Shield Advanced, AWS Network Firewall, VPC security groups, and Amazon Route 53 Resolver DNS Firewall. It also works closely with AWS organizations, which is essential for using Firewall Manager. So to start using Firewall Manager, you need to designate an AWS account as the Firewall Manager administrator account and ensure it's part of an AWS organization with all features enabled. Enabling AWS config and sharing with AWS organizations are crucial steps in the setup process. Finally, you must enable regions for Firewall Manager to manage resources within them. Once these initial steps are completed, they are ready to configure AWS Firewall Manager and its policies. So understanding DOS and DDoS attacks. So denial of service DOS attack aims to deny users access to a computer system or application by overwhelming it with bogus requests, rendering it unable to function properly. In a distributed denial of service DDoS attack, multiple sources flood the target system with bogus requests, creating a massive volume of traffic that poses significant challenges for mitigation. DDoS attacks are exhausted through botnets, a network of compromised computers controlled by dot masters who can remotely send commands to launch coordinates attacks on specific targets. Some common types of DDoS attacks include ping flood, which overwhelms a victim's network with pings, and SYN flood, which consumes servers' resources to make the system unresponsive to legitimate traffic. Understanding these attacks is crucial for implementing effective network protection and business continuity plans. So stay informed and stay protected. So AWS Shield and its protection levels. So AWS Shield is a managed service designed to protect your AWS application resources from distributed denial of service attacks. It automatically detects threats that may impact your environment and integrates closely with other AWS security services like AWS Web Application Firewall and AWS Firewall Manager. AWS Shield offers two protection levels, standard and advanced. The standard level is free and provides protection against common layer 3 and layer 4 DDoS attacks, while the advanced level offers enhanced protection against a wider scope of AWS services, including layer 7 attacks. The advanced level includes features like the Shield Response Team, layer 7 protection, enhanced monitoring, Route 53 health checks, protection groups, cost protection, and integration with AWS Firewall Manager. While AWS Shield Standard is free, AWS Shield Advanced comes with a cost of $3,000 per month. In addition to the data transfer out fees for all protected resources and requires a 12-month minimum subscription. Visibility and monitoring. Both levels provide insights into DDoS events, but AWS Shield Advanced offers additional monitoring features and the ability to gain visibility across multiple accounts. Amazon Inspector. Are you responsible for the security of applications, processes, and tools running on your EC2 instances? Amazon Inspector is here to help. Amazon Inspector offers a knowledge base with hundreds of rules mapped to common security compliance standards and vulnerability definitions. These rules are regularly updated by AWS security experts. You can also install an agent in the operating system of an Amazon EC2 instance to monitor behavior like network, file system, and process activity. With Amazon Inspector, you can automate vulnerability assessments to make security testing of EC2 instances a regular part of your cloud operations. These results in a prioritized list of findings, ensuring the security of your EC2 instances. Amazon Inspector, your solution for protecting the security of your EC2 instances. Amazon Guard Duty, an intelligent threat detection service for your AWS accounts and workloads. Amazon Guard Duty uses trained machine learning models to identify suspicious user and resource behavior, providing accurate threat identification of your account's data and workflows. The service analyzes CloudTrail logs, VPC flow logs, and DNS query logs to identify issues worth looking into, ensuring comprehensive monitoring and protection. Guard Duty classifies finding under three categories: low, medium, and high severity, providing a clear overview of potential threats. In the AWS console, findings are color coded and marked with symbols based on their severity, making it easy to identify and prioritize potential threats. Amazon Guard Duty offers a reliable and efficient way to consistently monitor and protect your AWS accounts and workloads for suspicious activity. Have you ever wondered how to efficiently discover and analyze sensitive data stored in Amazon S3 buckets? Let me introduce you to Amazon Mackie, a powerful tool that uses machine learning to do just that. Amazon Mackie leverages machine learning to scan S3 buckets and recognize critical private information such as personal identifiable information, credit card numbers, API keys, and access credentials. It automatically tracks changes to buckets, making the discovery job significantly more efficient and scalable. Mackie provides a detailed list of findings displaying the severity, finding type, affected source, resource, and last scan date. For example, it can identify objects with personal, financial, or credential related data and indicate the severity as high, medium, or low. With Amazon Mackie, you can run one-time or automated data discovery and display the results to AWS Security Hub, ensuring the security of your sensitive data. So let's dive into billing, pricing, and support resources in AWS, which includes AWS cost management tools such as Cost Explorer and AWS cost and usage reports. The role of tags in cost allocation, AWS support, customer support resources, and support plans. Cost optimization in AWS. AWS offers fantastic opportunities for faster development, lower total cost of ownership, and increased agility. Whether you are a startup or a large corporation, AWS grows with your requirements and always provides exactly the services that are currently needed. When used correctly, of course, cost optimization helps you meet your financial and business objectives while only paying for what you need and use. It's not about using AWS as a traditional data center, but about being agile and investing time in innovation. So, if you want to manage your resources and money appropriately and make economically wise decisions before expenses gets out of hand, cost optimization is the way to go. So the basics of cloud economics. So let's dive in, explore the value of cloud beyond just cost savings. One key aspect is the total cost of ownership. Cloud offers can achieve significant infrastructure cost savings through better supply and demand, matching elastic cost bases, and the elimination of hardware maintenance programs. For example, companies have seen a 50% reduction in TCO. Another area of improvement is staff productivity. Efficiency can be boosted through automation, the elimination of hardware related tasks, and increased developer productivity. Some companies have saved over 500 hours per year in server configuration time. Operational resilience. Operational resilience is also a major benefit with improved availability, security, and compliance. This includes reduced cost of planned and unplanned outages and an improved service level agreement. For instance, critical workloads run in multiple availability zones and regions for strong disaster recovery. Lastly, cloud economics can enhance business agility, leading to faster development of new features and applications. This is achieved through reduced time to market, increased operational agility, and a faster pace of innovation. Some companies have experienced a 75% launch of new products. In 2018, IDC found that companies using AWS saw a 62% more efficient IT infrastructure staff, nearly three times more features delivered, and 94% less time lost to unplanned downtime. Cloud economics is about more than just cost saving. With the right approach, the cloud can transform your entire business, making it more efficient and agile. Understanding total cost of ownership (TCO). TCO stands for total cost of ownership and is a comprehensive assessment of IT's total cost over time. These includes hardware and software acquisition, management and support, communications, end user expenses, and the opportunity cost of downtime, training, and other productivity losses. Using the cloud has greatly simplified the TCO assessments. Most additional costs are included in the cloud service prices, reducing the number of factors to take into account. For example, facility costs like space, power, and cooling are not a concern when using cloud resources. Understanding TCO is crucial for gaining a comprehensive overview of business cost and identifying potential issues and opportunities early on. Economies of scale at AWS. Economies of scale occurs when cost can be spread over a large number of customers. As more customers lead to higher AWS usage, more infrastructure is built, making the infrastructure cheaper and allowing for continuous price reductions. This cycle results in lower prices over time, benefiting both existing and new customers. With AWS, you can experience the advantages of economies of scale firsthand. AWS Cost Explorer, a powerful tool for cloud financial management within AWS. To access the Cost Explorer, head over to your billing dashboard and launch the tool. Once inside, you can visualize your usage patterns over time, identify underlying cost drivers, and detect anomalies. The Cost Explorer allows you to analyze your cost by different services, view detailed data tables, and even export the data for further analysis in tools like Excel. You can customize the time frame, group your data based on specific cost or usage, and refine your data set using various filters to gain deeper insights into your costs. Explore advanced options such as viewing untagged resources, analyzing cost as unblended or amortized, and even including discounts in your cost analysis. In the AWS Cost Explorer, you can effectively manage your cloud financials, identify cost saving opportunities, and optimize your cloud environment for efficiency. Understanding AWS cost and usage reports. The AWS cost and usage reports CUR is crucial for capturing AWS billing data. It provides granular, detailed insights into cost and usage data for all AWS resources. Enabling the CUR is essential for obtaining historical by the hour data, leading to accurate data driven insights and trend analysis. To enable the CUR, go to the AWS Management Console, navigate to the Building dashboard, and select the cost and usage reports from the left menu. Enable the CUR, create a report, and give it a name. It's advisable to include resources IDs for unique identification. Choose an S3 bucket to store the file, set a path, and select the time granularity for the data. You can choose to export the files for Redshift or QuickSight usage, altering the output format to be readable for Athena, Redshift, or QuickSight. Athena allows data analysis using standard SQL, while Redshift is a data warehouse service for acquiring big data sets, and QuickSight is a visually driven business intelligence service. After configuring the options, the CUR is set up, but it may take up to 24 hours for the first report to be delivered. Accept, expect minimal cost from S3 for storing the CUR data depending on the file size. AWS budgets. Let's explore how to set up automatic notifications and actions with AWS budgets to stay on top of your costs. To get started, head to the billing dashboard and click on budgets on the left. From there, you can create a new budgets and select from different types such as cost budgets based on actual costs or usage budgets based on usage like yours. Once you have chosen the type, you can set a budget amount and define your budget thresholds. You can also configure notifications such as receiving an email when a threshold is reached. AWS cost allocation and usage reports. Let's dive into the world of AWS cost allocation and usage reports. To effectively allocate cost, AWS enables users to tag every available resources. Tags provides the functionality to define metadata in the form of key and value pairs associated with the resources in a cloud account. With AWS cost and usage reports, you can track monthly AWS cost and usage associated with your AWS account. These reports contain the widest variety of cost and usage data and can be configured to show only the data that you want using the AWS cost and usage API. So planning out a staging strategy or standard is essential. It's best to keep tagging simple and easy to grasp and to adjust your tags to follow your KPIs once you determine them. In conclusion, with AWS cost and usage reports, you are able to store your report files in Amazon S3 buckets, update the report automatically, and make use of the AWS CUR API for automation or easier management through API calls. So start tagging your resources and gain valuable insights into your AWS costs. So let's start with some common tags that are used by most organizations. Some examples include cost center for business unit tag, used to show where resources costs are allocated within the organization. Another common tag is the service workload name tag, which shows which service the resources belongs to. Now let's look at some tagging best practices. First, align tags at your cost allocation strategy. Next, tag everything and find a purpose for each tag. Then limit the number of tags you adopt and keep it manageable. Consistency is key, so use a consistent naming convention. Automate tag management and set up policies to forbid launching untagged resources. Finally, Audit and maintain your tag regularly to ensure their purpose and relevance. Apply these best practices to your business or organization for effective tag management. Overview of AWS customer support plans. Whether you are an individual user or a large scale enterprise, AWS has a support plan tailored to your needs. Let's walk through the different support plans offered by AWS. From the free basic plan to the enterprise plan for mission critical workloads, there's a plan for everyone. Each plan offers unique features from access to customer service and communities to health, status monitoring, and notification. The availability of technical support, option for contacting support, and response times vary with each plan. The severity levels and AWS response times differ for each plan, from 12 hours for developers plans to 15 minutes for enterprise plans. The response times are tailored to the urgency of the case. All paid support plans receive some level of architectural guidance, but business, enterprise on ramp, and enterprise plan receives the most contextual support and specific guidance. Enterprise customers also have access to a pool of technical account managers and a concierge support team for account assistance. No matter the size of your organization or the complexity of your workload, AWS has a support plan to meet your needs. So, essential AWS support resources. Whether you are new to AWS or a seasoned user, these resources can be invaluable for your cloud projects. The AWS Knowledge Center is a goldmine of support resources, including frequently asked questions, videos, and guidance for AWS services and cloud migrations. It's a one stop shop for all your AWS support needs. AWS Professional Service or ProServes offers expert technical knowledge from your cloud projects, while the AWS Marketplace features software offerings from ISVs and AWS partners. These resources can streamline your AWS journey. In the unfortunate event of abuse and malicious activities involving your AWS resources, the AWS Trust and Safety team is there to provide assistance and support. There are just a few of many support resources available from AWS. Disaster recovery. Disaster recovery is all about restoring operations quickly with minimal data loss. These can due to catastrophic events like natural disaster or unauthorized access to resources. An effective backup strategy and redundant resources are crucial. RTO, recovery time objective, and RPO, recovery point objective metrics help establish the maximum tolerance level of business impact before regaining a stable operation state. There are a number of recovery strategies to consider when architecting in AWS for your DR plan to help you meet your RTO and RPO needs. These can be defined into four methods, with each one becoming more complex than the previous and usually more expensive, but with a decreased RTO and RPO at each stage. Backup and restore. These provides you with the highest RTO and RPO, and by high, I am referring to the time associated with your RTO and RPO metrics. Typically, a backup and restore provides in an RTO in 24 hours or less and your RPO in hours. Pilot light. This method decreases your RTO to a number of hours and RPO down to minutes. Warm standby. With warm standby, your RTO can be measured in minutes and your RPO in seconds. Multi-site active. This is the this is the most expensive recovery strategy. However, it does mean that both your RTO and RPO are close to zero. Introduction to machine learning and analytics services in AWS. These includes artificial intelligence and machine learning services like Amazon SageMaker, Amazon Lex, and Amazon Kendra. Data analytics services in AWS such as Amazon Athena, AWS Glue and Amazon QuickSight. Let's dive into Amazon SageMaker and the machine learning workflow. At its core, Amazon SageMaker is a fully managed service that provides the tools to build, train, and deploy machine learning models. It's where you go when you need to build, train, and deploy models. SageMaker fits into the platform services range along with other popular services like Spark, EMR, Databricks, and Data Robot. It's the go-to platform for everyone from level 2 upwards who is ready to start making their own models and prepping their own data. The machine learning workflow involves four key steps: preparing data, building the model, managing its training, and deploying the model into a production environment. Each step is crucial for creating and maintaining effective machine learning models. Amazon Athena is a fully managed service that enables you to interactively query data stored in an Amazon S3 data lake, as well as many other data sources, including data warehouses and big data repositories, all using standard structured query language or SQL syntax. This makes it easy to perform analysis on data sets up to petabytes in size without having to learn a new query language or provision and manage any infrastructure. Since Athena is serverless, you will only pay for the queries you run. Athena uses data definition language or DDL to define tables and supports querying data that stored in a variety of file formats including CSV, JSON, and Parquet. Athena also provides many other features to help you analyze and query data, including the ability to specify partition keys, allowing you to query large data sets by any column, integration with EMR and Glue, which makes it easy to perform data lake analytics, as well as QuickSight and Redshift Spectrum to create powerful analytics pipelines, and support for querying compressed data stored in S3, which can help reduce storage costs. AWS Glue, a fully managed ETL serverless architecture and tool that simplifies the process of categorizing, cleaning, enriching, and moving data reliably between various data sources. AWS Glue offers several key features, including the ability to create connections, use classifiers, and access the AWS Glue data catalog. The data catalog is a persistent metadata store for data assets containing table definitions, job definitions, and other control information to help manage your AWS Glue environment. When creating an AWS Glue job, you can choose a data source and a data target, customize the job processing environment, and specify how the job is invoked. The script is auto-generated and immediately available upon completing the job creation wizard. AWS Glue offers benefits such as serverless architecture, auto code generation, and integration with outer tool chains via custom endpoints. Pricing is based on an hourly rate billed by the second for crawlers and ETL jobs, as well as a simple monthly fee for storing and accessing the metadata in the AWS Glue data catalog. While AWS Glue offers many advantages, it's important to consider when not to use it. Factors to consider include an optionated nature of the technology, language limitations, and the maturity of the product. AWS Glue provides a powerful and cost-effective solution for ETL processes, offering a range of features and benefits to streamline data management. Amazon QuickSight. Are you looking for a powerful tool to visualize and analyze your data? Look no further than Amazon QuickSight. Amazon QuickSight allows you to easily process and analyze datasets from AWS and outside sources, creating detailed visualizations and sharing dashboards with anyone, regardless of their AWS knowledge. The typical workflow involves creating a new analysis, adding datasets, choosing fields, adding charts and insights, and finally publishing the analysis as a dashboard to share with others. With Amazon QuickSight, you can access, prepare, and report on your data making better decisions based on your findings. So let's dive into the world of AWS App Config, a powerful tool within AWS System Manager. With AWS App Config, you can control the development of feature flags and updates to applications running in AWS, ensuring they're always running in a desired state and changes are made predictably. AWS App Config allows you to create different application configuration, manage related configuration data, and apply updates to specific sets of instances before rolling them out to your entire fleet. It also integrates with CloudWatch alarms to roll back changes if an alarm is triggered during deployment. In addition, AWS App Config provides the ability to validate configuration, formats, and values before deployment, as well as track and roll back configuration changes, ensuring a smooth deployment process. So if you're looking for a tool to easily and safely deploy application updates to AWS while also providing powerful configuration monitoring and troubleshooting capabilities, AWS App Config is the solution for you. Are you looking to streamline your AWS operations? Let's talk about maximizing efficiency with the AWS command line interface CLI. Instead of manually performing tasks in the AWS console, consider scripting out commands and creating bash scripts for a more efficient and less error-prone approach to working with AWS resources. By using the AWS CLI, you can make the same API calls as the AWS console, but with the flexibility by accessing and managing resources through a terminal program. You can access the AWS CLI through various platforms, including a Linux shell, the Mac terminal, an EC2 instance, or a program like Putty for PC users. Ready to take your AWS operations to the next level? Try out the AWS CLI for a more efficient and flexible resource management experience. AWS Cloud9, a cloud-based integrated deployment environment IDE that's changing the way developers work. AWS Cloud9 is a cloud-based IDE that allows you to write and debug code from any location as long as you have access to a supported browser and an internet connection. With Cloud9, you will create a development environment which is a server that stores your files and code for your project, and an IDE that's tied to this environment. You can choose between an EC2 based environment where AWS manages the instances and the tools for you, or an SSH environment where you manage your own servers and tools. Cloud9 offers a full-featured IDE with real-time peer programming, direct integration with AWS services, and support for several serverless applications like AWS Lambda. The best part is there is no additional cost for Cloud9 itself, just the fees for the underlying servers. AWS Cloud Shell. AWS Cloud Shell is a browser-based Linux shell experience that provides secure, pre-authenticated access to AWS CLIs and other tools from within the AWS Management Console. It's a convenient and powerful tool that allows developers and administrators to interact with AWS services as the currently logged in user without needing to set up a local development environment. To access Cloud Shell from the AWS console, simply click the Cloud Shell icon in the top navigation bar. This icon will appear in any region where Cloud Shell is currently supported. Cloud Shell pre-configured environment includes the AWS CLI, CLIs for Elastic Beanstalk, ECS, and the AWS Serverless Application Model SAM, as well as commonly used command line tools like Python and Node.js. Plus, with up to 1 GB of persistent storage in your home directory, you can install any additional tools you may need. So if you're looking for a hassle-free way to interact with AWS services and tools, AWS Cloud Shell has got you covered. AWS X-Ray. Analyze and debug production and distributed applications. AWS X-Ray is a distributed tracing system that helps developers analyze and debug production, Distributed applications, such as those built using a microservices architecture. With X-Ray, you can understand how your application and its underlying services are performing to identify and troubleshoot the root cause of performing issues and errors. AWS X-Ray provides a complete view of requests as they travel through your application and filters visual data across payloads, functions, traces, services, APIs, and more with no code and low code motions. AWS Code Build, a fully managed build service designed to streamline your development process. First, let's talk about the core concepts of code build. You will create a code build project, specify a build environment, and define a build spec file to manage your build process. The build environment is crucial. You can choose a managed Docker image or create a custom one, supporting various runtimes like Java, .NET Core, Python, and more. Next, you will need to specify build commands. You can do this directly in code build or use a build spec file for more complex process. Finally, you will decide where to save your build artifacts, typically in an S3 bucket, and monitor the build status using CloudWatch. And that's a wrap. AWS Code Build simplifies your build process, making development more efficient. Now let's dive into overview of AWS Code Commit. If you have ever spent time writing or maintaining code, you're probably already familiar with Git repositories. They enable multiple developers to work on the same code bases without overwriting each other code and provide versioning so that if something goes wrong, developers can roll back their code to a positive state. These Git repositories are hosted in source control services such as GitHub, GitLab, Bitbucket, and the star of the show today, AWS Code Commit. AWS Code Commit is a fully managed Git-based source control service. It's often the starting point with CI/CD setups, kicking off other steps of the pipeline. It's a well integrated with AWS Code Build, AWS Code Deploy, and AWS Code Pipeline. Code Commit is designed to be simple from the infrastructure level to the service functionality, supporting all familiar Git commands and using the same technology as other popular source control systems use. When creating a repository, the only significant requirement is to give the new repository a name. There are three ways to connect to a repository via HTTPS, SSH, or HTTPS. Code commit encrypts repository data in transit and at rest by default, integrates with IAM, and provides fine-grained identity-based access to repositories. The pricing for this service is based on the number of active users of your repositories. For each active user, you receive an allowance of 10 GB month of storage and 2000 Git requests for that month. AWS Code Deploy for CI/CD pipelines. Let's dive into the key concepts and terminology to understand how it streamlines application updates. AWS Code Deploy automates the deployment of build artifacts, ensuring quick and effortless application changes. It's designed to make new features available to end users as early as possible while avoiding system downtime. In Code Deploy, you will encounter three key terms: application, deployment group, and deployment. When using Code Deploy, the first step is to create an application and select the platform to deploy your code to: EC2, on-premises, Lambda, or ECS. Regardless of the platform, you will need to specify the deployment configuration to control the speed of your deployment. Options include all at once, canary, and linear deployments, each offering different level of safety and control. For EC2 on-premises deployments, the code deploy agent is essential for communication with the service. Once the agent is installed, you can create a deployment using the selected deployment group and revision. Code deploy integrates with CloudWatch and SNS to notify you of changes in your environment. allowing you to detect and react to deployment events. With AWS Code Deploy, you can streamline your CI/CD pipeline and ensure efficient and reliable application updates. Automate your CI/CD process with AWS Code Pipeline. Let's dive in and see how it all comes together. AWS Code Pipeline is the tool that brings it all together, automating the orchestration of your entire process. It monitors your repository of changes, triggers the pipeline, runs code build to generate a new artifact like a Docker image, and then runs code deploy to push the generated image to your network infrastructure. Your pipeline can be customized to fit your specific needs. You can have different build and deploy stages using various sources like code commit, GitHub, or Docker images, and monitor everything with CloudWatch events. Once your pipeline is set up, any changes in your repository will automatically trigger the pipeline. Code build will generate the artifact, and code deploy will handle the deployment, all seamlessly orchestrated by code pipeline. After the deployment, you can easily confirm the success of your deployment and see the results in the real time. AWS Code Pipeline is a powerful tool for orchestrating your CI/CD process. Ready to streamline your CI/CD process? Try AWS Code Pipeline today and experience the power of automated orchestration. AWS Code Star. Let's introduce you to AWS Code Star, the tool that simplifies the process of setting up and creating a CI/CD tool chain. AWS Code Star is designed to take the pain out of building a full CI/CD workflow. It allows you to quickly launch from pre-built CI/CD workflow template tailored to the characteristics of your software development project. With AWS Code Star, you can have a fully working CI/CD tool chain or operational in a matter of minutes. It provides a unified single pane view of your build and deploy workflow, allowing you to focus on your energies on building new product features and shipping them faster to your customer base. CodeStar provides a step-by-step wizard driven process for provisioning a new project, allowing you to pick from pre-configured project templates and specify the attributes to your software project. You can set up and configure a team of users within your project, granting role-based access to other users with different roles like owner, contributor, and viewer. That's a wrap on this introduction to AWS CodeStar. Ready to simplify your CI/CD workflows? Amazon AppStream 2.0 and Amazon Workspace. Amazon AppStream 2.0 is a fully managed end-user computing service that securely streams application and provides virtual desktops to users worldwide. It supports application running on both Windows Server and Amazon Linux too. Users can access their applications from anywhere using the AppStream 2.0 client or a web browser and authenticate using federated sign-in with any SAML 2.0 compliant identity provider. Amazon Workspaces provides users with persistent virtual desktops, allowing you to provision Windows, Amazon Linux, and Ubuntu Linux desktops. It's a robust replacement for traditional desktops or VDI environments without the expense and labor required to maintain your own VDI solution. Workspace can be configured to automatically install patches and updates during predefined maintenance windows and can be provisioned with additional software such as Microsoft Office already installed. In summary, while both AppStream and Workspaces can be used for virtual desktops, AppStream is ideal for streaming individual applications, especially legacy ones, while Workspace is a more robust replacement for traditional desktops or VDI environments. Thank you for joining us for a quick introduction to Amazon AppStream 2.0 and Amazon Workspaces. AWS Amplify, your gateway to full stack application development on AWS. AWS Amplify provides a comprehensive set of tools and services for configuring, deploying, and hosting applications that run on iOS, Android, React Native, or the web, all while utilizing AWS services. Amplify tools include an open source framework with libraries, user interface components, and a command line interface for building your application backend. It also offers built-in support for authentication, analytics, offline data, and push notifications. Amplify Studio, a visual design experience and a fully managed service for hosting web apps and static websites with full stock CI/CD are also part of the package. AWS Amplify boosts support for multiple frameworks and libraries. Figma integration for importing design prototypes into React code and integration with AWS Device Form for testing apps on real iOS and Android devices, as well as different web browsers. AWS AppSync, a fully managed service that simplifies the development of serverless GraphQL and pub/sub APIs. AWS AppSync allows you to access data from multiple sources, including DynamoDB tables, Amazon OpenSearch service, or any HTTP data source, and combine them into a single network request. Plus, it offers server-side in-memory caching for low latency data access. One of the standout feature is its ability to automatically update data in real time across all connected clients using GraphQL subscriptions, providing a seamless and responsive user experience. And don't forget, you can configure real-time updates without using GraphQL through AppSync's PubSub API wizard. With AppSync, you can integrate IAM rules for access control, Amazon Cognito user pools for authentication, and configure CloudWatch for logging and monitoring, and X-Ray for comprehensive tracing for your GraphQL APIs. Plus, it supports resolvers for custom business logic and advanced data processing using AWS Lambda as a proxy to your own custom data source. So, if you're looking for a powerful, flexible, and user friendly solution for developing APIs, AWS AppSync might just be the perfect fit for you. Let's dive into a overview of Amazon Device Farm. It's an app testing service that allows you to test and interact with your Android, iOS, and web apps on multiple devices simultaneously. With hundreds of iOS and Android devices to choose from, is the perfect solution for all stages of application testing. Amazon Device Form offers flexible testing methods, including automated test using built-in test or custom scripts and manual testing with the remote access option. The service also provides secure testing environments, non-rooted iOS and Android devices, and the ability to catch potential issues during the development process. Say goodbye to the hassle of maintaining and updating physical testing devices. Try Amazon Device Form today and streamline your app testing process. AWS Internet of Things Services (IoT), IoT Core, and IoT Greengrass. AWS IoT Core is a fully managed platform that connects IoT devices to the AWS cloud without the need to manage your own infrastructure. It includes a registry to enroll and track IoT devices, supports messaging infrastructure for secure and low latency message processing, and provides a rules engine for data processing. IoT Core supports popular communication protocols like MQTT and HTTPS. Now let's talk about AWS IoT Greengrass. It provides client software and an open source edge runtime environment for running IoT applications across entire fleets of devices. Greengrass enables processing data streams directly on IoT devices, implementing messaging between components, and deploying secure over the air updates. So, whether you're looking to connect IoT devices to the cloud or run IoT applications across fleets of devices, AWS IoT Core and IoT Greengrass have got you covered.